us in Brussels to start?
Microphone.
No, we're here.
Okay.
Good morning.
Then you are hearing us, right now?
Yes, good morning, that's fine.
Okay, very good. Shall I share my screen with the agenda, right?
Yeah.
Okay,
I stop sharing.
great. So, welcome.
Nacho, se tienes que conectar esto
No, ¿me están escuchando? Ya me han dicho eso.
para compartir la agenda. No,
Yeah, no, you can share it with the
¿En Teams?
okay, okay.
No.
teams. Yeah, yeah.
Creo.
Sí, sí, sí.
So hello everybody. Good morning. We are here in Brussels to hold this workshop, this webinar/workshop about digital ID management in decentralized environments, data management, sovereignty, and DLT. And I will shortly present you what will be the agenda for today. Slightly, I will present how it is composed and how we will proceed with different aspects, which will be held as well via this platform. And then afterwards, I will pass the floor to the speakers, starting with Rolf. I will just share the screen for a second. Okay. So as you can see, we have a full agenda for the whole morning, starting now 9:30 till 1:30 p.m. And we will start with the intervention of the European Commission representative, Rolf Riemenschneider. And then we will start with our first block, which consists of a panel about data privacy, centralization or decentralization. This key question about how we are facing the key challenges in distributed energy resources, because we are contextualizing all the debate today about centralized or decentralized in energy prosumers, demand, production environments, together and coupled with IoT, edge, cloud computing, and how the technologies help. So here we have certain panelists that will have short interventions, starting with a keynote pitch by Professor Jens Strüker. Later, we will have questions and some of debate with the audience, and it will be followed by another twin session of a panel. Now this time more focused on real, hands-on experience in the field of the energy by relevant industries that are participating. The second panel about the industry takeaways will be led by Dr. Oscar Lázaro, which is also present already here in the room. Finally, we will have a shorter session which consists of presentation by relevant related entities such as clusters or projects or more technologically oriented perspective in order to conclude the workshop. Before starting, let me state that we are looking forward to your interventions, and also the panelists will be answering your questions. If you have any kind of comment, you can use also freely the chat and we will address the questions. So, having said that, I will pass the floor to Rolf Riemenschneider to start the session, and thank you very much, everybody.
Thanks, Nacho. Good morning, everyone. Very welcome. I'm happy to host both Nacho and Carlos as coordinator of O-CEI. And with me is also Thomas Ebert, yes, it's early in the morning, as a colleague of Mas. So I'm very happy to have that workshop because you hit us in the middle of a new wave of actions and activities, the first 100 days of the Commission. And like that, I'm very happy to give you a bit of a policy update. Not an update, but maybe, to show you what we are working on at the moment. So I will try to share my screen. And I want to, yeah, there we go. So you should be able to see it now. Okay.
Yes.
Can I continue? Yes. What drives us at the moment is what we call a new agenda called the competitiveness compass of the EU. I don't go into much of the details today, but we have three main pillars. We have 1, 2, 3, 4, 5 horizontal actions and 3 main vertical pillars. Reducing excessive dependencies, closing the innovation gap, and decarbonization and competitiveness. So the last one actually is the one, which is most relevant today because we are addressing cross-domain, cross-sector activities. So under that decarbonization and competitiveness, you have an action plan of affordable energy, an electrification action plan because electricity is also cost-cutting, and business cases for e-mobility, heatings in buildings, efficient capacity use of the grid, and renewable energy integration. So it's part of the first 100 days. So we have to define the actions at the moment, and we have to be very specific. So from that point of view, the workshop was very timely, and I hope we have a good discussion today. But before jumping on the new thing, we have a bit of a backlog of legacy. You see that in yellow, it's all the digital actions on data, and the blue ones are the vertical actions. So these have been launched in the last commission with different angles, looking at greener energy systems, decarbonization, the Green Deal, but building also on European strength and driving competitiveness. So the big question also is today, how to combine competitiveness and green. It's a challenge, but looking what is sort of linking the yellow and the blue ones, it's a bit all about data sharing and data access. Looking at what we are interested in is cross-sector data sharing. So what are the standards which are going cross-domain, cross-sector? But also the other part for sharing data, the blue ones in particular look at, that you need registration of those who create the data. So registry and ID management. So from that point of view, it's very important topic. So I mentioned data sharing is a key issue. So that's, why vertical sectors have started legal provisions for sharing data. I don't go too much into details. You have the Renewable Energy Directive identifying real data sets for EV battery data. You have the AFIR for sharing data from charge point operations and the Data Act as a mandate for data sharing. So there are different provisions. So not going to details today because we are more interested what we call the registries created. Also, bonjour Pierre. Sure. Also for the registries, there are legal provisions already. One of the most popular ones is the digital product passport, but we're also thinking about the digital battery passport. We're thinking about national databases of buildings. There is the European product registry for energy labeling and so on and so forth. And then you have that in the yellow part, it's the particular registries for individuals and companies, which are also important, but also, have a bit of variety where, people have to identify themselves and to be recognized as a trustful partner for sending data or for sharing data. So all that classical registries are more or less defined on a central basis, pretty centralized, do not cover everything, and it's not conclusive, and some of them are overlapping. And the big question is, could we somehow simplify in the future, or do we create another registries if we have a further demand for energy sharing? So that's a bit of a question. So what is behind that? If you look at the picture, normally data sharing is not a big deal, if the two people know each other. But if they're not fully aware of themselves, you need a trustful identification of who is sending the data, where does the data come from? And you have to distinguish between individuals who normally have a passport, or you have to distinguish between connected assets or Internet of Things devices. And there you have a bit of a question, can you trust them or not? So devices have to be registered in order to send trustful data. So this ID management for individuals, in particular also for assets and energy assets, because energy is cost-cutting, is a key issue. So what we are working on at the moment is what we call a flexibility register for any devices who have something to do with energy management. So it's proposed by TSO task force, and it includes data information about the resources which seek to be participating in flexibility markets. And basically, it has two modules. One is the asset itself. So what is the device, a heat pump or a charge point? And the other one is who is providing the service. So who is managing, who's supervising the exchange of data, which is the service provider. And then, on the right side, you have the bit of what you know from the market. The most big companies, IT companies, have a cloud device registry. If you buy an IT device, you have to register it in the cloud service and it's registered, but somehow it stays in a silo. Or, which also starts to evolve at the moment, we have completely localized registry. You mean a gateway or an edge controller, but then you don't have an app. So if you want to have an app, you need the internet connectivity, and then you need sort of cloud service. So, and how do we do device identification? Then you have the whole portfolio of different protocols and standards, and which have to be interoperable, and which do not really link the identity of the devices. So there we have fragmentation again, but mostly it's linked then to what we call standardization of protocols, standardization of formats, and then it goes in that direction. Good. What we discussed today is definitely, the issue of distributed or central transactions. We see later on a discussion about IOTA and to link it to connectors from Gaia X, from IDSA. But what you all know is the central registration. If you use PayPal or Amazon, Amazon is used for payment services across the Amazon marketplace. So again, you're all aware of the central registration, and I don't need to dive into that, but clear, it's central, it's the major IT companies, and you have a bit of a vendor login. Good. With that, there's a bit of hope for the assets in particular, if we have sort of a harmonized, unified registration on ID, which could be a digital product passport. And with that, I pass the floor to Thomas, who's working on the file, and he will tell us, isn't there some hope in the tunnel, some light in the tunnel to work with that, or we still have to be patient? Thomas.
Yes, good morning also from my side. I will try to put it in 3 minutes, what usually the presentation goes in 1 hour. So I try to focus really on the main parts, also linked to the topic today about the digital product passport. So to understand where it comes from, it's important to understand it's coming from the Eco-Design for Sustainable Products Regulation, which is a framework regulation, and means that it has to be put into practice by delegated acts for specific product groups. So the Eco-Design for Sustainable Products Regulation, I will call it ESPR in the next minutes, allows the Commission to provide delegated acts for specific product groups, setting information requirements or also performance requirements. And the information requirements will mainly be in the digital product passport as the central tool or the central place where all information is stored. It's important to note the digital product passport is supposed to be decentralized. So the information stays with the economic operator who puts the product on the market. But there's also an element of centralization, which is the central registry. And for the whole discussion, I think this slide is always very important to differentiate. There's on the one side the question about which data is in the digital product passport. What information do we need? And this is a discussion which is parked a bit for the moment. It needs to be looked at the product level to really understand for this product group what information do we actually need. And the other element of discussion is how to set up the technical and IT system for the digital product passport. This is a discussion which is ongoing at the moment. It's also contains a lot of different elements. So one I already touched upon is the central registry. This is supposed to only host the identifiers, so the product identifier, the identifier of the place of manufacturer, and the operator identifier. That's the main task for the registry, to centralize this, to also allow a link to the single window from the customs authorities. There's another element which is about the standardization, so which standards to use, and I marked in bold one of the standards which are currently drafted, and this is about the unique identifier, so how to identify objects and how to identify companies. This is currently ongoing, and I put you the link to the standardization mandate. the idea is not to invent something new, but the idea is mainly to try to look what is on the market, what is existing, which fulfills the requirements, and then to point at different standards already existing to put the digital product passport in place quite fast. Another point which I forgot to mention about the data which is in the digital product passport. This is not only exclusive to the eco-design delegated acts, but it has an opening clause saying if some other legislation wants to use the digital product passport, you can use the digital product passport if it's available for that product. So that's a bit about the design of the digital product passport. And on the next slide, I will show a bit the timeline. I will not bother you with the past and the history. Just to explain you what's currently ongoing is the discussion about the eco-design working plan. So which products will be in scope of the digital product passport, or which will have a digital product passport in the later stages. There will be in late this year or beginning next year, hopefully, a delegated act on digital passport service providers. So companies who want to host digital product passports for others. And when you look at the slide, you see with the red marking, the first digital product passport needs to be in place in February 2027. And this is the digital product passport for, I call it large batteries. So at the start, mainly electric vehicle and stationary storage batteries. And later on, further product groups will get a digital product passport. We expect around 27, 28. But this is only the timeline for the ESPR, and that's also where the digital product passport comes from. But there's additional legislation which makes use of the concept already. So there's a discussion about digital product passport for detergents, for toys in the toy safety regulation. So other pieces of legislation try to use the same system to create something which is universal and not have different tools and different registry all over the place, but to have one tool which can be used for different purposes.
Okay, thank you. So as such, you will see some products who will have it already quite soon, so 2027. And there are opportunities to test the system to see whether it's versatile, whether it can be used. At the end of the day, we talk about market adoption. And if you look at markets, particularly at where we need cross-sector orchestration, it's definitely the link between e-mobility, living, buildings, smart cities, as well as energy. And then we had a report recently, and some of the authors also part of the discussion today, and Strüker is in the meeting. And you can download the report, you can read it, you see on the recommendations. Identification is one part of it to link the different sectors before we go to interoperability standards. So that drives us because we have to look at the market. What is the drivers on the market? We see some people in Germany say we talk about a tsunami of batteries going for the home. We talk about e-mobility, in particular Scandinavian countries, where a lot of electric vehicles are put on the market with a huge asset which you put on the market, which could also be used in the energy system. So for the time being, we also see gaps, to link the different sectors, but also there are also gaps in investment because the grid has to follow. So that is a bit of the challenge where we're operating, where also the pilot O-CEI is operating and is part of a cluster of different pilots where we want to put evidence. What can be demonstrated, what is available, and what is the added value for the industry and the different sectors. So we hope we get some inspirations on questions today to have an easy onboarding of devices, to use IDs, what are available, and to look what is the added value of DLTs, distributed ledger platforms, and blockchain. At the end of the day, we want to build open platforms and emerge an ecosystem because we also have open calls, and we look at what are the cross-domain standards, including IDs and other interoperability standards. With that, I pass the floor back to Nacho as part of the coordination team of the O-CEI, and wish you all a stimulating discussion and happy to be here. Thank you.
Great. Thank you very much, Rolf and Thomas, for your good introduction, setting the way for the rest of the discussions today. And having said that, I just take the floor and pass it to the introduction for the first panel to be done by Professor Carlos Palau, who is the coordinator of O-CEI, the project with these pilots related to this energy sector. The title of the panel is Data Privacy, Centralization or Decentralization, Key Challenges in Distributed Energy Resources. So, Carlos, floor is yours.
Can you see my slides? Or
Wait a second. I have to see where am I now?
I'm sharing.
You have to share it.
We are seeing them.
Yeah, yes.
Okay, there. Okay. I shout a lot, but in any case. Okay, thank you very much for attending. Thank you, Rolf. Thank you, Nacho. Right now, a fast presentation for the panel because the important message has to be provided by the panelists. So the idea of this panel is to deal and discuss about data privacy centralization or decentralization and which are the key challenges for distributed energy resources. So we are moving, and this is the view that we have coming from O-CEI. We are coming from a previous centralized power paradigm, and we are going to a clean local distributed power that we will be having not tomorrow, it's even today. Okay, here we have key elements in this architecture that we will be dealing with in the O-CEI pilot project, that are the different distributed energy resources, the different smart meters that are providing data in different places by DSOs, and we have, of course, the smart grid that they have a crucial role in every production. And additionally, we have all the data, i.e. artificial intelligence and analytics for energy flexibility that we are having in the edge, in the devices and in the cloud. And this will bring us new business model. This is what we are planning to provide in O-CEI, and this is something that will be supported by the technical aspects that are being provided in this panel. We have a clear opportunity, and I will not, it's the same that we have seen before. It's a longer presentation. So we have different data that is showing us that we have an outstanding opportunity. The business is growing. The size of the segment in energy and everything related with energy flexibility is growing. The market is growing even at 10% per year, and we are installing a lot of units in different elements. We have different ideas from the batteries, from the e-mobility, the electric cars, different aspects. All of this, we have pilots in O-CEI. We have a different aspect, that is the green energy transition, that is a top priority. The need of artificial intelligence processing in the edge, that is key for the DERs, and additionally, scalability and distribution in the continuum for the decision. So we have here three pillars, that is the data, the openness, and different cooperative success stories. That is the things that we want to provide in O-CEI. Openness, because we want to reuse different open solutions, and data, because we want to harmonize data flows, and for that we may need this decentralization of authentication and identification. So these are the key challenges for DERs that we have identified already. We will be moving. We need balancing privacy and accessibility in order to use these centralized or decentralized solutions, regulatory compliance that we have already seen in different slides, different risks related with cybersecurity that probably sometimes they, let's say, stop a little bit the introduction of different aspects, scalability and interoperability and trust and data ownership. Who is going to own the data at the end of the day? So from the CEI ecosystem, or O-CEI and CEI-Sphere, that are the ones dealing or starting working with the workshop, what we can provide is local data processing and anonymization, decentralized access control, end-to-end encryption and secure storage, regulatory compliance and data sovereignty management, and resilience against cyber threats. We can develop this, and this will be developed during the two different panels during the workshop. And just for introducing as concrete actions coming from the panel, we will have a keynote provided by Professor Jens Strüker from Fraunhofer Blockchain Lab, okay, dealing with Web3 technologies and how can be leveraged decentralized identity management for DERs and allowing efficient participation in different markets and ensuring data privacy and security. We will have also Mr. José Cantera from IOTA, And we have seen that the IOTA tangle is key in this decentralized identity management. And we also will have Mr. Jan Peters from Power Ledger, who will show which is the role of blockchain in decentralized energy markets. Okay. So for me, the presentation is done. So now,
Okay.
thank you.
Thank you very much, Carlos, for your introduction. I think that we can directly start with the experts in the field. We are all eager to hear them about the topic. So the keynote pitch has been assigned to Professor Jan Strüker. I am not sure if you are here. Yeah, I am here. I think so. He's already sharing the screen. Hello, Jens. So from our side, the floor is yours, and you can proceed. Thank you very much.
Yeah, good morning, everybody, and thank you so much for having me. Just a quick test. You can see my screen, I guess, and then I would start. Wonderful.
Yeah, we can see it, yes.
Wonderful. So yeah, we already heard a lot about the role of the new energy resources we have. Most of them are distributed, and it's a great number. So the question is, what's the role of this flexibility in the energy transition? I would say we all can agree that they have an enormous potential there. I think that we are not talking enough about the necessary secure and verifiable data exchange here. That is required to make this a success. And what is particularly important here to me is that we can ensure competition in the offering and demand for flexibility and flexibility services. And there's a strong connection to public infrastructure. What kind of infrastructure do we need here? And Rolf already mentioned the role or this kind of idea of a digital spine. And I think this would be part of my talk or little presentation now. It's about the necessary public infrastructure and also about the trade-off between verifiability and data sovereignty. So imagine the following scenario. You drive your EV from Brussels to Cologne, and there you start charging at a public charging station on the street. And once you reach, I don't know, 70 or 80% of your battery capacity, then the local grid operator offers you a good price to reduce your consumption. And this might be due to a bottleneck situation, congestion, etc. in the grid. And then 10 minutes later, and imagine we will have Whitsun, for instance, in the summer, on the early summer, and electricity prices on the market would turn negative. And so you offered the opportunity to charge even longer and get money for that. So all of this would be, I think, highly desirable and would greatly facilitate electrification. But of course, the challenge here is these potentials are currently very, very difficult to leverage. Or even further, I would say, if I look especially to Germany, I would say that these scenarios will fail today because, among other, there are a couple of reasons, but one of them is, of course, we have a national asset registry in Germany, but this does not even recognize EVs. Additionally, roaming, as in the telecommunication sectors, is not possible. So the question is, or the thing is here, mobility and the energy sector are not integrated. How can we do that? And by the way, of course, this holds also true for heating sector, of course, with heat pumps, etc. It's the same. I think it makes sense to take step a moment and take back a moment, sorry, and to really get a good impression, what are the costs behind that, what we are doing today, and what what we will face in the future. I can say that here you see a very, very simple illustration, but I think if we if the cost of a business as usual approach, I would say they could become very, very extremely high. Yeah. So imagine or think about all the different situations when we try to handle, to process data manually. This is what you can see here is just a rough estimate, of course, but it clearly illustrates how costly and inefficient the repeated manual processing of master and transaction data really is. So the discussion, for instance, Rolf also mentioned that the onboarding of assets, on easy onboarding of energy assets into energy system, it's so much work today, and workforce, you need a lot of workforce for that. But the other thing is, of course, the question of if you want to change market roles here. So again, this is sometimes it's not possible. Sometimes we have to face a lot of regulation challenges here, but on the other side, it's again today, you in Germany, for instance, you would write a letter to do this, to change your market role, yeah, from feed-in, for instance, to have to make use of your battery in different roles within a market or a system or a grid services here. So for that, I think it's a good, we can really make clear that we need a kind of digital infrastructure there. And you agree on that, of course. Let me just mention one other aspect here. And it's connected, of course, to the question of switching market roles. So I think that not having a digital spine means that we slow down system integration even further. And this means a significant welfare loss in the future. I'm talking about proprietary technologies and vendor lock-in here. Households can only participate in these services today and the flexibility services today via their original equipment manufacturer. This holds true for heat pumps and EVs, of course, and other aggregators, I think, which act as their market representatives as well. So if you look about think about the home energy management system and the batteries and so on. So this market access restriction, I think, could leave a vast portion of flexibility potential untapped. And then the question, of course, is, how can we address this challenge? We propose open sourcing all relevant DER data and making it direct accessible to their owning households or companies. And we think that verifiable and trustworthy data is essential for unlocking this potential. And such an approach achieves three key objectives here. We think that by providing open and transparent data that can be independently verified, we establish trust in the accuracy and reliability of flexibility services. So this means ensuring data verifiability. And then, of course, tamper-proof and auditable records enable fair and forgery-proof transactions for services rendered. And of course, it removes then barriers allowing any household or provider to participate in flexibility services. This is what we call democratizing market access here. So, and with a digital spine, this really can deliver an approach to face this. This does not mean that we have a kind of one solid block of technology here provided by one company or so, or one unit. This is not the case, of course. So we mainly talk about digital spine as a concept to think, okay, what is proprietary technology? What is maybe a more public concept behind that? who has access to what. This is the kind of political and social debate we need on that. But at the end, it comes down, we can boil this down. Rolf mentioned that to interoperability, of course. And this is the key question here. So if we now go further, we see we have a couple of digital technologies to do that. We think that with Web3 technologies like digital identities, SSI, blockchain DLTs, etc., edge computing in general, if we combine that, we have a lot of different options here. And this is important to make clear that it's not one technology, it's the mix of them, and then, of course, how we use them. And one trade-off, or before that, so if we bring this together, our overarching targets here, our digital technologies we can choose from, and then to look what different building blocks we have here for working on that, this makes our digital spine. And for details on that, how this could look like, I would like to refer to the study we conducted for DG Connect, and you can find the link here, of course, in the presentation. So one key challenge then, if we go one step further, in the context of building such a digital spine, then is the tension between verifiability and sovereignty, or data sovereignty. Data privacy, I would say, is one part of that. On the one hand, to give you a very easy example, a simple example here, a grid operator manages critical infrastructure and must be able to clearly verify assets and their data, and I will come to that later. And on the other hand, there's a sensitive data that households and businesses do not want to share with each other. So in a project, and this is about a redispatch, or in the center of this project is a redispatch 3 process. We came up with a kind of trust diamond to work on that, to handle the challenges here. And the idea is, of course, on the one hand, we have companies like Tenet, so critical service manager here, or manager for critical services in the grid. And they say, if we one day want to really manage assets lower than 100 kilowatt, then we really have to prove what kind of device are we talking to interact with, of course. So the question here is, how can we do the identity management here? One thing is, you have to know this is a car, this is a car, or this is a heat pump, etc. If you want to allow somebody else, an aggregator, to do his or her job here. And then you have the transaction data. Does this data really comes from that asset, and so on. So we see for critical infrastructure, this seems to be very reasonable, etc. But then maybe we have some electricity provider, and they say, I just want to provide a tariff, dynamic tariff. So why do I have to have this kind of very high security level, etc., or the requirements are not necessary for us. We are just talking about historical transaction data. So the thing is here, if you want to switch market roles, then all of them have to understand what is a car, what is an asset, and so on. We have different security layers here, definitely, and different requirements, but nevertheless, they have to understand each other, and that's the key here. We cannot think the grid part and the market part totally separated. This does not work. And then even further, if you go to things like DPPs, the product passport, digital product passports, and think about, oh, this is information that is so important for regulators, for companies itself, for investors, and so on. So energy plays also a very crucial role here. Where does it come from? And then we see we have cross-sectoral things. We have to have a common layer here. And this means in the trust diamonds, we have to work on that. Our technologies, and now I'm with the technology level, I think it's important that we are open about the different possibilities and options we have here. I'm a big fan of DLTs, of zero knowledge proofs, etc. The challenge is, of course, how can we bring that together, work on them, and already in a kind of laboratory environment, very early, work on that and find out what's possible. Think about the problems with DLTs some years ago when it comes to scalability, etc. And I think we will talk about that later on. It's very important, I think, that we really focus on what's on the technology side is possible. On the other side, what is our goal here? How can we create interoperability and competition so that the not only onboarding of assets is important, but also from a competition perspective, that we can really avoid things like new big platforms coming online here. So that is definitely a threat I see. So for the takeaways here, I think that a kind of digital spine concept with all the different approaches we see coming up with on the technology side from data spaces, etc. It's I think a wonderful approach now to combine these different sectors, approaches. We have concepts we see. Think about EIDAS today and EIDAS a couple of years ago. Nobody spoke about EIDAS, combining EIDAS with DPPs and blockchain or SSI, zero knowledge proofs 5 years ago, or not so many at least. I'm very happy about that. And I think that Web3 technologies are important, but it's just the beginning today. And I think I will end with the issue here that digital identity management for really trusted IoT platforms are absolutely crucial to facilitate really an easy onboarding for flexible energy assets into the electricity grid and to guarantee a high level of openness when it comes to competition. Yeah. Thank you.
Okay, thank you very much, Jens, for your great presentation. We are very glad to see how the IT, this digital spine you suggest, can make the mix for actually providing this open platform and enabling the exchange and the implementation of this trust among the grid operators and the participants in the actual exchange. So it's absolutely fantastic. Advancing into the inner presentations in the panel, we are clearly linking them to what you just said. First, we are having one of the companies in Germany that actually own an open source tool that tries to implement this zero trust and decentralized way of mechanisms for establishing such trust. And then later, we have an actual company that is applying the concepts of enabling this exchange and flexibility, and with real implementations based on software, hardware, and different countries in Europe. So I think they are a very nice complement to the introduction you made. Therefore, we kindly ask you to remain here so that you can answer any questions if there are some later when the panel starts. I'm thanking you again for the introduction. I kindly pass the floor to this 10-minute speech assigned to Mr. José Cantera from IOTA. So Please, José, the floor is yours. You can proceed.
Yeah. Hello, everybody. So I am going to present. So I hope you are seeing my screen at the moment.
Yes, we can see it.
Okay, perfect. So thank you very much, first of all, for the project, O-CEI project, to invite me and IOTA to this workshop. So I am going to present a little bit about myself. During 2023 and 2024, I was until first quarter of 2024, I was leading the final phase of the European blockchain services pre-commercial procurement sponsored by the EC, where we were exploring how to leverage all the EU blockchain services, particularly EPSI, to the next phase. And there we develop different stuff, including different digital product passport pilots, but also how the IOTA technologies, the IOTA DLT, could leverage and scale properly and do data sharing properly and apply all of that in a massive scale. And it was successfully evaluated. At the moment, I am involved in evolution of that work. We call an infrastructure. We are building new infrastructure based on IOTA for value chain ecosystems, and it implies, of course, one of the most remarkable value chain ecosystem is the digital product passport. And yeah, I've been working 25 years in the sector and involved in different standardization activities with GS1, HC, W3C, and others. So regarding IOTA, as you know, originally it's a foundation, a non-for-profit foundation in Germany, but now we have three different entities, not only the foundation in Germany, but also two satellite entities, one in Switzerland and one in the UAE, because we are expanding the ecosystem. So we not only do the pure DLT research and development activities, but also ecosystem development activities and projects that can enlarge the adoption of DLT. And today, well, we are going to talk about DLT and review what can bring DLT to trust and to DPPs and to all the problems that your project is going to tackle, but also some review of what was our experience and where we are heading to. So regarding DLT, well, you know that the ledger, you know what a ledger is, no? An information store that keeps the immutable record of transactions, and in particularly the DLTs shared, replicated, and synchronized, you know. But the four main features are transparency, immutability, traceability, and non-repudiation, and of course, the execution of immutable instructions, which are smart contracts. So these are the four pillars, the four features, that the DLT is providing. And on top of this, we want to build this new generation of decentralized systems, decentralized applications that can exploit this capability. And in IOTA, we are evolving from, you know, an initial version of the Tangle, initial versions that we explored the graph-based technology, the DAG technology, into a more advanced, I would say, offer in which we have two different layers. Both of them are programmable with smart contracts, and the layer one is a move VM smart contracts that can be programmed with a decentralized consensus, with an object model ledger. This is an evolution from the previous version where we experimented in the PCP. So this is a more, I would say, performant and scalable version. And on top of that, of course, the developers that are very used to Solidity, to the Ethereum virtual machine capabilities, they can also build on top as well. So we have this dual network landscape, and that makes the technology very powerful, because you can have both smart contracts on layer 1 based on the move language, or you can have smart contracts, traditional Solidity smart contracts in the layer 2. And essentially, the technology that they directed a cyclic graph technology, it has been proved to be much more, the throughput that can be obtained is much higher. And essentially is because you can have parallel execution of transactions, but also an object-centric model allows you to be more efficient when you update the ledger. And on the other hand, as you are more efficient, you can increase the throughput, etc., etc. So that's the capability that we are offering with IOTA, and which essentially we are offering all the DLT capabilities, but not in the traditional blockchain, but more on the graph-based, directed a cyclic graph-based technology. So if we have this distributed ledger and we have these different capabilities that we reviewed before, how we can leverage on that. And of course, the first one is having identity, and you know these three elements. You know, the issuers, holders, and verifiers, that they can with these three roles we can build trust, a certain level of trust. And there are the decentralized identifiers that are anchored to the IOTA layer 1, where the different identities are registered. But on top of that, you need credentials issued by some trust anchors in the ecosystems. And this is what we are showing here. So we are going to need certain trust anchors. So trust anchors can be governments, can be revenue agencies, can be conformance assessment bodies, whatever. And then there are compliance participants, so the ones that are attested by the trust anchors. And these participants can be economic operators, can be, of course, public authorities, etc., etc., and they are going to need to exchange data. And of course, we are going to know who they are because they are registered on the ledger, and they also have certain credentials that can be discovered as well, or can be presented, where we can attest and we can share data with them. So there, thanks to the trust frameworks based on the DLT, we don't need to have an a priori knowledge about all the participants. These participants, of course, can interact without this a priori knowledge, because there is a distributed ledger that will help to do so. So that's a very, very important point. And regarding the architectural blueprint, another aspect is not only identity, but also using the distributed ledger technology, using it for enabling verifiable data that the previous colleague presenting was mentioning. And of course, there is always the question is, should be all the data in a DLT? And we are saying essentially no, because DLTs are not good at indexing data. But yes, there are certain data that there is need to be in the DLT, and this is the commitments to the data. So essentially, in the case of the DPP, there can be the data controllers, so the people that have the data of the DPP, they have the data in their system, but of course, they can have commitments on the DLT. So when I ask them, oh, please me give this information about this product, I can give that information, but I can also show a proof about that information, when it was generated, what was the provenance, etc., etc., that can be in the DLT. So this is one of the key aspects. So that the capabilities that the DLT provides, immutability, time stamping, sequencing, can be used to increase the trust and to have verifiable data. And that's a very important point. So having that into account, or taking that into account, this is our blueprint architecture for DPPs, in which you can have different data controller services, and they control the data they have, and they implement attribute-based access control. But in the end, the different participants, either DPP writers, so actors that are writing data, or readers that are reading data, they use their identity. Their identity is in a verifiable registry like IOTA, and they query these services. And of course, they can present a credential. So that credential, of course, can be subject to selective disclosure, etc., and presenting that credentials, and depending on the attributes, they can get access to the data they need. And of course, data sovereignty is kept. There is trust between the different actors through the identity, but also the data is verifiable through certain commitments that are registered on the IOTA ledger. So this is our blueprint for verifiable data. And in digital product passports, this is something we experimented in the pre-commercial procurement of the European Commission of the EU blockchain services. And well, this is our blueprint, but what we did with this, where we experimented with DPP for electronic devices, where with the Politechnical University of Catalonia, where the problem around devices and how devices change across time, because you can change your configuration, can be solved with this architecture. And we saw how different device hubs could talk each other, different data controllers, and how you could even get data in a foreign device hub through the verifiable presentations, etc., the corresponding protocols. And then, and then we also did another DPP experiment with plastics and the recycling of plastics, turning plastics, regular plastic into bioplastic, and how all those changes were verifiable, but also you have a passport around your new products, because from regular plastics you can generate bioplastics, and how those bioplastics, the provenance, etc., can be obtained with data from the different actors, because we have recyclers, then we have the producers of the new, I would say, intermediate products that allow you to manufacture the new bioplastic, etc., and we have the different trust between the different trust anchors, etc. So it was pretty interesting to validate our ideas, and it was very successful results. And at the moment, what we are doing, well, essentially, we are building a consortium, which is called TWIN, with different relevant organizations, including the Tony Blair Institute, the World Economic Forum, and we are building on top of IOTA, and with our experience in distributed ledgers, we are building TWIN. It's an open platform for value chain ecosystems, and the general idea is to merge the good stuff from data spaces, DLTs. So you will see there are data spaces connectors, nodes that interchange data, assuming the fact also that there are existing systems that they need to provide the data, and you need to share the data. And of course, the DLT technology to build this new platform where the different actors can exchange data. You can build ecosystems that work, that they can be the DPP ecosystems to share data in different DPP, in different sectors that would need the DPP, but can also be applied to international trade and so on and so forth on typical supply chain use cases. So we are, from this previous experience, we are leveraging on all IOTA to build this capability with data space connectors and all the open approaches that the European innovation ecosystem is developing. And we will do this as currently IOTA is open source. We will all this platform as well open source, because we think this is key to enable the DPP in this in this context, but also not only DPP, but also other ecosystems. So this is the end of my presentation. Thank you very much, and open for the further questions later.
Okay, José, thank you very much for your great presentation. It's nice to see real examples and also to hear about this twin consortium you are forming for generating this open platform. For me, also from the technical side, I might have some questions later about this, but it's great that you came in with these ongoing actions that you are undertaking, also real practical examples. So thank you very much, José, also for having accepted the invitation to participate. And please remain available just after the next presentation for further questions. And I'm sure that there will be. Great. So moving forward now to another company that's specialized on applying actual technologies in DLT in the energy market, really to the point where we are discussing today. I am pleased to introduce the next speaker and the last one for this panel, who is Mr. Jan Peters from Power Ledger, and with a presentation about the role of blockchain in decentralized energy markets. So the floor is yours, Jan, for a presentation. Thank you very much in advance.
Yes, thanks, Ignacio. And yeah, thanks to everyone else involved in the organization of the event. Yeah, very happy to present our the Power Ledger's view on the role of blockchain and how we see blockchain can unlock benefits from decentralized energy markets, decentralized energy resources. And just quickly about myself, so I'm product specialist here at Power Ledger since a few years. So I've been involved in the design, development, and development of our transactive energy trading platforms, and in various pilot projects and commercial projects that we've operated globally. Hope you can see my slides actually. Ignacio, can you confirm?
Yes, you can. Yeah.
Okay, awesome. So just briefly about Power Ledger as a company, because I assume not everyone has come across Power Ledger yet. So we've been around since roughly 9 years by now, and Power Ledger is specialized in development and deployment of software platforms that focus on the trading, tracing, and tracking of renewable energy. And through that, we want to enable the accessibility to cleaner and cheaper electricity. And as mentioned, so we've been we are a globally acting company. So our platform is currently available in around 14 countries with active projects across five continents. And with our platforms, we are always trying to address problems from address the two problems that we see really as the most prominent that currently energy markets have when transitioning from centralized systems planned around large-scale baseload generation and predictable generation to markets that are focused and centered around renewables, and specifically variable renewable energy, so solar and wind resources. And for that, we mostly consider from the angle, we have the time problem and the place problem that inherently are a consequence of deploying large resources or large amounts of resources of those two energy types or energy resources. And we need to solve those to transition the markets to provide 24/7 clean, renewable, and carbon-free energy. And to give a little bit more context about this, so I'm sure most of you will have seen similar visualization of the graph on the left side, showing the time problem that I was describing. So the prominent display of the duck curve. So this data that you see here is from South Australia, which is the state in Australia with the highest penetration of variable renewable energy. And in that state, but it's not the only state, in Germany and other countries, you have the same phenomena, where over a very short period of time, like large amounts of solar, distributed solar, especially was deployed and then has like impacts on the operational demand profiles in the network. So you can see, like, for example, in South Australia, like within 5 years, the demand during the main solar generation hours was like halved roughly. And this like has huge consequences for the operation of the grid. And the second one, like the spatial grid problem or spatial problem, is like the disconnect, or it is not always the case, but often disconnect between the availability of like natural resources, like solar and wind resources, and the actual demand centers. And here you can see the example of Germany, but the same can be said about Australia as well, and other countries with advancements or progressive advancements in like deploying variable renewables. And so we really see as market changes that can like unlock or like bring remedies like to these like two problems that we're being faced with. So currently, like in traditional markets, so we have we like identify like the the bottom layer, the gray layer here is the household or the end customer layer, who's then connected to the energy markets like via intermediaries, energy retailers, utilities to buy and sell energy. And our view is that additional market layers in between those two could really unlock benefits from the bottom up to support the wholesale market as well at managing like the effects of like those new energy resources that are deployed like at the lower grid levels. The first one I want to speak about in more details, like the peer-to-peer local energy market level, decentralized energy market level, or energy community, whatever you want to call it. And then above that, or like in this layer where energy customers can exchange energy with each other via like blockchain enabled platforms. And then above that, connecting like the local areas, the flexibility layer where cross regional like energy communities can be connected, or through like virtual power plants, community storage, demand response programs. Flexibility can be shared between energy communities, and this then relieves like strain from the bottom up to the top layer. So I want to focus on what you just saw here, the layer 2 for now. That's like the area we are most actively involved in at this stage. So the decentralized energy market, and we define the decentralized energy market as like a community of electricity end users that are connected via like a blockchain enabled software trading platform, where they can view their generation and usage details, where they can submit prices they want to buy energy at from their peers or their other members of the community they're part of. And this like brings some inherent benefit to all stakeholders, like including the customers. And for the customers, we through that, like, we provide an additional or an alternative revenue stream for prosumers, especially in times of falling feed-in tariffs, falling subsidies for solar. We provide like reduced electricity cost for consumers that participate and that do not have access to renewable assets directly in the way that prosumers do. So this can be a use case for apartment buildings as well. The platform provides like improved visibility over energy consumption generation profiles, also for the energy retailers and network operators. And it provides access to verified renewable energy for everyone involved. And it keeps for other stakeholders in the network, like the distribution network operator, provides benefits of managing export and imports at the local level without like involving higher up networks levels, and therefore like reducing need for like additional network services or redispatch measures. And so the role of blockchain, we see then why we bring blockchain into the picture.
Jan, please, sorry, kindly ask you to condense the presentation in only 2 more minutes so that we'll have time for questions, please. Thank you.
Okay, no, yeah, I think like this has been mentioned by José in the previous presentation already anyways, like most of the benefits that blockchain brings, decentralization, removing the need for centralized authorities, recording transactions in a tamper-proof way, and also high transaction throughput. And like in our ledger, we also see that generation through blockchains are really the enabler that is required for scaled, decentralized energy markets because of just the sheer throughput of transactions that are required. So even in smallest projects, we can already see a vast amount of transactions, like on a micro scale, sub kilowatt hours, and so on. And I just want to mention like energy efficiency as a big point for Gen 3 blockchains as well, especially Solana should be mentioned here as a prominent example of newer version blockchains, because it lowers the energy usage of blockchains by like vast amount, like over 99%, like in compared to Bitcoin or generation 1 blockchains that operate on like proof of work. And just very briefly, like the solutions that we see as providing most benefits here are like the peer-to-peer energy trading, grid flexibility, which I spoke about earlier, and then the trading of environmental attribute certificates, like renewable energy certificates, and then lastly, like transparency and tracking and tracing solutions for visualization of grid energy mix, for example, which could be used for EV charging with verified renewable energy or PPA procurement solutions. I'll stop here so we have some time for the Q&A. And yeah, thanks for listening.
Okay.
The opportunity.
Thank you very much, Jan, for your presentations. Now it's the time for sparking the debate about what has been discussed. And for this, if I'm not wrong, we have the actual coordinator of the Coordination and Support Action CEI-Sphere in the room with us, which is Tania Suarez from BlueSpecs. Hello, Tania.
Hi, Nacho.
We'll pass the floor to her for shortly sparking the debate and motivating the audience for panel debate. Thank you, Tania.
Thank you very much, Nacho. Thank you very much also, Jen, José, and Jan. That was incredibly interesting. And I think that you provided a lot of detailed information there on some of the opportunities, but also the challenges that integrating this new approach to decentralized energy management can bring. So could I first of all encourage anyone who's in the audience to pose questions? I don't think we've got a specific Q&A section here, but if you just put them in the chat, then I'll make sure that that we leave some time to ask those questions. But while we get the ball rolling there, could I first of all ask Jens, what do you think are the main adoption barriers for using these new technologies in a DR environment? I mean, Carlos mentioned privacy and accessibility. He mentioned 4 or 5 others. But from your perspective and from your experience of speaking to multiple stakeholders, what are you seeing are the common barriers to people actually taking this on board and integrating it into what they do?
Yeah, so the main barriers I see, a couple of them. So one of them, I think, is proper integration at the hardware level. So we will face the classical, traditional Oracle problem here, of course, and this must happen from my perspective at the hardware level. And this is challenging, of course. One way is we can go for the transition phase. We have a lot of things in place today. So retrofitting via Raspberry Pi, for instance, is definitely an option. It's possible and it's good for speed here, but I think it's not viable on a long-term perspective here. And then I think OEMs, they must participate, definitely. And for various reasons, of course, they right now, at least, they have not so many benefits here. So I see little benefits for them or even disadvantages. And we have to integrate them, their perspective and their interest. And then last one, perspective from our different projects we did. One is, at least in Germany, I mentioned this project DEAR with a large German and Dutch TSO. German regulations, they pose definitely challenges to data usability. We have a meta law, and there we prescribe that every data, also billing data, have to go via our very, very secure smart meter gateway. And we are the only ones in Europe doing this.
Okay, that's an interesting one. I think one that we can, also take up in future recommendations. Can I just ask you, before moving on to the other panelists, and you mentioned OEMs must participate, and actually at the moment they might even have some disincentives to do so. Is that from a financial perspective? Is there a lack of return on any investment that they might make? You mentioned hardware challenges, for example. Could you just elaborate a little bit on that?
Yes. So easy example is, I think, if we think about bidirectional charging. So a car manufacturer, this means additional hardware. Of course, you can argue we have so many SIM cards in a car today. That's true. But here we are talking about something different or additional. So at the end of the day, it's cost. But like always, I mean, there are disadvantages and advantages. And if you show them, of course, you can make use of them. Bidirectional charging, this can be a service for you, also for your own fleet management, and so on. And there are, as you know, there are a lot of projects going on, trying to find out what are the benefits here. So it's just a question incentivizing, coming to a good framework.
Thank you, Jens. José, same question to you then, please. What are the main adoption barriers specifically for maybe taking on this decentralized approach to identity management?
Sure. So I am going I agree with what has been formally said, but I will take the perspective of a developer and a builder, and building a decentralized this system is always more challenging. It's always difficult, because the solution that as engineers comes first is say, okay, I put all my data here and everybody get access. And having a decentralized system is very challenging from an engineering point of view, but also from a governance point of view. So because in the end, the ideal situation is there are no privileged actors, but that is difficult. It's easy to be said, difficult to achieve. So that's one point. Another point, in the adoption of DLT, there has been, from my point of view, two barriers. One is the technology. The technology is still evolving, and there are different or different proposals, from a technological point of view, and there is a need of standardization and the need of, and the way of standardizing might be also like we did in databases. There are different vendors, but there are like standards like JDBC in databases. So we can have connectors, and these connectors can ensure that different ledgers can be used, and there can be different ledgers of reference where the ecosystem can be built on. And that was the idea of EPSI, having a ledger within Europe. But we can have other ledgers, even public ledgers, which can play a role here. But here is when it comes another issue, which is privacy. So how we ensure that these actors that they want to share data, they don't disclose through transactions in the DLT, even if there is no the data itself. Through these transactions in the DLT, you may end up disclosing like volumes of transactions, etc., that give you an indication of your market size, etc., etc. So that's also a barrier. And the third barrier is, of course, companies. There is a gap between innovation cycles and and the real day-to-day basis. And companies tend to go or with what they have now, and the adoption cycles take longer, you know, and that's also another barrier. So that's the summary on my side.
I think that, and thank you very much. Also very interesting, and I think you've touched on a couple of points there. And Rolf and his colleague in the opening session was very much pointing to the issue of standardization, and that's going to be one of the key areas which we're going to be focusing on within the CSA. So we'll definitely come back to you with some questions there to further that. We've got something called the hourglass, which actually looks at, you know, where the connectors need to happen. So I'll make sure that the data piece is absolutely in that already. You also touched on the gap in innovation cycles within the main economic actors and what the market is actually requiring or what the technology is actually enabling. And again, I think that's key to making sure that we're competitive in the future. You know, that the way that we innovate and the speed at which we innovate maybe is putting us at a slight disadvantage in the market. So again, something to pick up as we progress, and to feed into the pilots. Let's look at the pace at which we're able to develop things and make sure they're getting to the next stage. May I now ask the same question to Jan? I mean, again, you know, you have a more global perspective. You mentioned some work there that you were doing in Australia. What are you seeing as the main differences in the adoption rates, but also the barriers that exist across your multiple ecosystems?
Yeah, thanks. So yeah, I think a few that have already mentioned, we definitely experienced this way. I'm doing like pilot deployment. And like, for example, the interoperability challenges of standardization. I mean, that's something we experienced, I guess, in most of the project, because there's so many different stakeholders involved normally in a project. Like us as a technology provider and metering company, network operators, retailers, everybody using a different system. That makes it challenging for sure, especially also in the terms of the smart metering recording of like smart metering data. There's like many different formats used. Like, I mean, I think in Europe, I assume there would be more standardization, but yeah, globally, that has definitely been a challenge. And other challenges like the regulatory uncertainty, yeah, has been like a main blocker for us as well, especially transitioning from pilot stage to like commercial deployment. So we had, for example, I give one example, like we had a pilot project in Southeast Asia with like 1,000 participants, but it could not, we couldn't progress it to commercial stage because there was no regulatory approval in place. Hence, we had to do it without any actual billing integration. So it was more of a like paper pilot, like using their metering data. And then other challenges that we experienced were also hardware challenges, like, you know, smart meters not being in place, or smart meters not sending data, internet connectivity issues on the sites. And I think the last one I just want to touch on is like user engagement as well, what sometimes could be an obstacle as well. In some cases, users not like being familiar with like added solutions that we like to introduce. So that has been like some challenge in certain pilots as well. Yeah.
Thank you. So I think that's the first time I've heard from somebody on a panel saying that actually regulation is a good thing, and it's unlocking. So having that regulatory framework within Europe is actually going to be unlocking some adoption there. So thank you for that.
I mean,
if I could, yeah, sorry, go ahead.
Yeah, I just want to say, like, I mean, it's in, you know, in comparison to other markets that we're in. I mean, I think in Europe it's definitely in a more advanced stage than seeing it from a global perspective. Like, for example, in Australia, it has been really challenging with certain markets in Southeast Asia as well. But in Europe, at least, we have, like, yeah, the, you know,
clarity.
from the EU.
Thank you.
Some
Thank you.
yeah.
So coming back to you, Jens, if I may, can you, because we've only got 4 minutes left for the panel, could you name 3 technical challenges or recommendations that you would propose for pilot projects within O-CEI, but maybe also beyond that, to apply in their real life environment demonstrations? Because it's, you know, we I think, again, as Jan has just mentioned, one thing is to deploy a pilot, but then, you know, you're going to hopefully take that pilot deployment into a real live environment. So what are the things that we need to take into account from the moment that we're actually initiating those pilots technically?
Yeah. So one, of course, is standardization. If you think about data models, etc., between different sectors, and this has to come, I think, from the industry itself. This is important. Otherwise, it's not possible to realize to do this. Then second, I would say I already mentioned that secure hardware binding. This is the second one. And third, yeah, I think we need common federated governance, a kind of, at least. If we look at data space, etc., just an example, my perspective as a scientist on that is I see it's successful in parts, but how bring we all the different sectors together and who's managing that? So there is a governance, an overall governance, very important challenge here we have to solve.
Thank you. And again, that's something that we have in CEI-Sphere. So good that you've confirmed that that's actually something that will be useful for the pilots. Same question to you, José, please. So what are the 3 technical challenges or recommendations you might want to make to pilots, given your experience in this field?
Yeah, so essentially one is not reinventing the wheel, is just rely on existing standards and recommendations. And for instance, in data spaces, the work is being done with Gaia-X, but also the OpenID, Connect standards, IETF. So just build on standards. Second is build using with a view that a distributed ledger provides this layer of these 4 capabilities of immutability, transaction settling, smart contract execution, and on top of that you can have your connectors, so different connectors that extract away the DLT that you have, and that way you can, in the end, we can go towards interoperability between different DLTs, and all of this scale in the end. So that's the second one. And the third one is privacy is important, and you need to take into account what should be stored in a DLT, what should not be stored in a DLT. It's an important point. So these are my three points.
Thank you. And I think that's a key principle, isn't it, of data management? Just keep what you need and disregard the less. So no data hoarding by anyone. And finally, the same question to you, Jan.
Yes, I was gonna say standardization as well. I'll skip that because I think Jensen also mentioned that. Then I think like scalability, I would say, is like a big topic for us as well. And comes hand in hand like with transaction cost, especially from like blockchain systems. So I think like using like newer generation systems is like really important for scaling like energy communities or the solutions that I was speaking about to minimize cost and just ensure that real-time transaction and settlements can be carried out. And then the last one, I think like important is also to have like redundancy to like outages, because like one is like operating something like in a sandbox environment where it's it's okay if like you don't cover like all the time steps and there's no like billing integration with retailers, but then in commercial implementations where you then actually implement like into or have billing integration with retailers and have an effect on the energy bills, and it's like really critical to just be redundant to that meter readings and yeah, other like integration with other assets is not always available. So like creating redundancy systems, for example, through then like having catch up if readings are coming in later or interpolation or whatever this is in place to cover like those periods.
Mhm.
Perfect. Well, thank you very much. Professor Jan Strüker, Mr. José Cantera, and Mr. Jan Peters, thank you very much. And Nacho, back over to you.
Thank you very much, Tanya, for moderating this session. We should move to the next one, but before moving, I would like to reserve 2 minutes in case anybody here would make any question to the panelists. Maybe Thomas or Rolf, or we should continue.
Fine.
Okay.
Fine from my side. Should we go maybe for 5 minutes break? I don't know.
Okay. Yeah.
So
okay,
Nacho, then if we do have a couple of minutes, then there is a question from the audience here, which is how this is from Antonios Ingelzakis, asking how do DLTs face data tampering on the low level at sensor nodes or edge devices? Is it required to deploy validator nodes next to the edge? So for any of the panelists who can answer that, I'm guessing José would be the best, please.
Well, that's a good point. That so essentially the validators, it depends on the on I would say governance and organization or restrictions, I would say, on your operation. So it could be interesting that each participant in an ecosystem could run their own validator, but there can be certain participants that it is not economically viable for them, or it is too much. So because you need to manage the validator and it implies certain, I would say, IT operations, etc., etc. But of course, having a validator closer where the data is being generated is going to be, in terms of confirmation, in terms of delays and the delays and I would say latencies that you may have until your transaction is confirmed could be good in that case. But it has to be evaluated. If from an economic point of view, etc., depending on the network you are using, but also on the requirements, software requirements, hardware requirements, etc., it makes it interesting, or you need to use validators provided by other members of the ecosystem. So depends.
Thank you very much, José.
Thank you very much for answering the question in the chat. So we are going to move to the next panel right now. It's okay. Okay. We didn't have it planned, but if you want to, I think we're okay. Maybe later we will have more time. Yes. So moving to the next panel about industry takeaways in key sectors. We have several representatives of the industry here today. We are very looking forward to hearing from. But the panel starts with a presentation by Dr. Oscar Lázaro from a company Innovalia to introduce the panel named Industry Takeaways, Key Challenges and Trends in Decentralized ID, Data Sovereignty and DLT for Energy in Cloud-Edge IoT. So if you are hearing us, Oscar, now the floor is yours.
Hello, Nacho. I hope you can see my screen already.
We can see you on not yet your screen.
Now the screen is fine or not yet?
No, it's actually blank. No, we cannot see any.
Now it's coming. It's here.
Yeah.
Okay, so
we do have it now. Yeah.
You have it there. Okay.
Yeah.
So very quickly, this is just the introduction. So 10 minutes, as Carlos mentioned in the introduction of the previous panel. What is important is not this introduction. I think is more important the insights that the follow-up presentations will provide. In any case, to provide a little bit of background to the presentations today and what we are trying to discuss. I think the previous panel has focused mainly on the discussion about the technologies. Here we are trying to bring some light in terms of why we are making these discussions, which are the type of industrial steps and advancements that we are trying to implement. But and since at the end of the day, what the industry is trying to facilitate with all these initiatives is to bring forward new economic spaces. So we have seen that from the single European market, we are evolving with new forms of digital markets like the common data spaces, and then we are starting to discuss and to realize the importance of interoperability and AI power systems that can realize and support this competitive decarbonization of industry through new instruments like the data union. In terms of industrial challenges that are really bringing forward the use of all these discussions about identities, about different data governance approaches, we have to realize that in industry, we are at the entrance of a new era, where actually today's peer-to-peer type of exchange and management of operations are no longer fit for the job that we have to implement. We live under new geopolitics and innovation conditions. We have to face regulatory and sustainable requirements, and we have to do this in sustainable economic terms. So this presents new challenges and new scenarios. And the siloed approach that we were discussing before are no longer valid operation models. We have to face three main challenges in terms of making industry sustainable, but at the same time competitiveness. We have to make industry resilient, and we have to deal with global supply chains that need to be energy efficient. And at the same time, we have to comply, and we have to comply with industrial platforms and digital networks that will have to work together. Behind these very overarching themes, what lies is the need of bringing together business cases on the twin transition that are combined with increases and solid levels of competitiveness. How industry is actually working in terms of making affordable energy available to multiple industries that are engaged in these decarbonization processes, and from the policy level, how the things are actually being harmonized and integrated into consolidated approaches that bring decarbonization, industrial, economic, and trade policies under one single approach. And we should not underestimate the challenges that I believe Rolf and the colleague from the commissions from the Commission were introducing at the beginning of the workshop in terms of the regulatory mandates that we will have to face in the very short term. And in many cases, the implementation of these new regulations, like the DPP that we will discuss in a few minutes, actually naturally call for the development of trust at the global level. So as we understood this morning, it is not only industry, but as well the European Commission that is putting forward what is called the competitiveness compass. That is basically the framework with three transformational imperatives to boost competitiveness, supported by 5 horizontal enablers that should bring industrial competitiveness forward. In the discussions today, when we look at the different initiatives that are going to be presented in the next minutes, we have to start to relate the implementation of this project, of these initiatives, with the first 2 pillars of this easy competitiveness compass. Initially, pillar 1, that is really making sure that we are having access to state-of-the-art infrastructure, state-of-the-art digital networks and services that can realize this capability of leveraging global trust based on the harmonization and adoption of international standards. To realize that no single digital solution fits all needs, particularly when we are talking about cross-sectorial solutions and we look into the implementation of decarbonization solutions. So we have to be able to provide freedom of choice in terms of digital solutions. Also to make sure that the scale-up of these solutions will have to accompany different investment budgets. So this ability to scale with the level of budget and investment is also part of the new capabilities that the digital strategy should support. If we look at the pillar 2, that is the actual pillar that is looking into the decarbonization, combined with the competitiveness of all these decarbonization actions, we realize, and we will realize that with the presentations today, that these solutions are not only cross-sectorial, but they should be implemented and designed and implemented by design with the global approach in nature, to make sure that all these solutions that are connected to the management of the energy systems and its application to the different sectors can realize high level of customization and flexibility, since the demands on the energy and the different implementations, as we were discussing before, will be highly personalized and highly adjusted to the actual implementation budget. So how we are able to implement this customization, this flexibility in the implementation of decarbonization strategy is one of the challenges ahead. If we look at the different enablers, what we should or what we are aiming at in terms of implementation of solutions, we see a nice parallelism between the different approaches that we will be presented today in terms of how to make the solutions simpler, how these solutions allow better coordination between the member states, between the different countries, even outside Europe, and ensuring this by means of application of different standards that are actually adopted and implemented at global stage. So the use cases and the different initiatives that we will listen to in a couple of minutes are actually trying to reconcile the digital development of different enablers like generative or agentic industrial AI, the different applications of the industrial metaverse, the data spaces, the digital twin, that they have been implemented and they will be continuous the implementation over the next year with a number of different challenges and trends. What we see in terms of trends on how to bring together all these different technologies is the need to increase the capabilities in terms of autonomy and orchestration of digital network and services that are characterized by a multi-vendor environment. What we also see is the need of these trusted data transactions that are performed not only inside single sectors, but across a number of sectors at global stage with transparency and efficiency. And when we talk about this digital industrial ecosystem, where we aim to implement this continuum of technologies that we will have to deal in terms of ID management or in terms of implementation of data governance, we see the importance of making next steps in terms of supporting standards in the implementation and to implement this at scale. When we bring all these challenges under a unified framework, just a few comments for the Manufacturing X initiative that will be presented today, where we make sure that open solutions that allow these global industrial data transactions are bring under shared services, technical foundations, standards, and regulatory framework. And actually, this is what enables the implementation of these cross-sectorial business cases for large industry and small, medium enterprises at a global scale. How we realize and how we make progress in implementation this type of vision is what the speakers will be presenting today. We will start the panel with a short presentation from Dr. Thomas Hahn from OPC Foundation, International Manufacturing Council, and Siemens AG, that will bring a further understanding on how all these discussions on DPP, global standards, and manufacturing X at international level could actually leverage all these different technologies that we are dealing here today. Then we deep dive a little bit more into how flexibility in energy distribution, energy management can actually be realized with the presentation from Mr. Matthias Schumann from EDF. And we try to bring together the view of how digital twin standardization can actually bring together a manufacturing mix solution with energy use case in the context of data exchange, data transactions related to data spaces. This will be presented by Dr. Matthias Bolke from IDTA and Schneider. And then we look for more specific examples on the importance of tamper-proof assets in renewable energy communities and EV battery, passport from Berhan Peishel from ABL. And finally, we see how asset administration cell DPP 4.0 can work together in the energy domain with a short pitch from Max Helgmin. And overall, the industrial panel will be followed as the previous one with some question answers that will be moderated by Nacho later on. So Nacho, with this short introduction, I think I get the floor back to you so you can introduce Thomas for the first keynote of the panel.
Yes. Perfect. Thank you very much, Oscar, for the great introduction to this session. And without further ado, I just pass the floor to Thomas, who, as you said, belongs to OPC Foundation and a Siemens Fellow in Siemens AG, and also participates in relevant initiatives, including presidency of VVVA. So I think he will explain better than me his role and his speech. So please, Thomas, if you can hear us, the floor is yours now.
And hopefully you can hear me too. Many thanks to make a short intro speech, covering a little bit manufacturing verticals, like Oscar said before, which meaning from the factory floor, so to say, but also to the energy distribution, and hopefully showing you a little bit where are the topics where we have some kind of joint architecture, where we have to look inside, where we can also propose some kind of our thoughts which we have here. And for sure, you will see this later also when Max or Matthias referring on the others referring to this, how this interconnect. Okay, I hope you see my slide here now. Can you see my slide?
Yeah, we can see it, yes.
Okay,
Thomas,
perfectly.
yes.
That was a final check. And my role, many thanks for introducing me. Right, I'm a fellow at Siemens AG, and therefore, besides the internal task I have regarding technology, I'm active in different external committees. Oscar mentioned OPC Foundation, some kind of standardization setting body to have connectivity and describes this. And I'm also at the moment heavily active in this manufacturing arena, especially on the international level, but I will touch this in some slides later. Maybe to setting up, and I think we mentioned before digital IT, you mentioned before also DPP, and you mentioned also regulations, but also in our case also business opportunities in for example footprint management or recycling, sustainability. You can extend the list. But I want only to start always with a short example, and I want only to focus on the second example, only to give you a feeling when you have a battery. You know, when you know how the battery is used, produced and used, and recycled, you can see done very much more efficient like be done today, because today you are looking in the battery and then you have maybe not knowing what is the status, what are the materials, how is the production data included inside. But when you have to do this, let's say really have this along the complete chain, when the battery is produced, then you can recycle much more. And therefore, and now I'm handing over going over to a battery passport, and this is an example from the Cantera, because it's showing, from my feeling, very good how, let's say, is along the chain from the mining up to the recycling, in between the producing, the building the batteries, for example, into a car, so to use the battery as an end user, and of course to have this remanufacturing. This is somehow this chain you here see, and you see here, let's say, some kind of categories of data which is collected during this lifetime of the battery. And you see here how is this added, how is extended, and so on. And you can imagine this we have to look how DPP can look worldwide. And included in this is for sure also, say, the ID management, because you can imagine you have, don't ask me how many legal entities are participating in this value chain, from the mining up to the recycling of the battery. Only to give you a feeling why we are touching this, why this is important, why this is important for our economy, but also why it's important for us when I speak as industry, what we have to target this in a joint and global way also, and fulfilling our own values for sure. But battery is also a good example that we have to really to look on a global scale in doing this, because as you know, some of the material used in a battery is not available in our regions. Therefore, we set up, let's say, some kind of initiative, and Manufacturing X is an initiative where we have several projects contributing to this initiative. And you see here in this corner a little car. This is, for example, the Cantera X, where I just referred to regarding the battery passport. You see here an power plug, which is a little simple when we are speaking about the energy. You see here part from chemical industry. This is more where you have some kind of discrete manufacturing and so on. And this is what Oscar has shown before, where we're looking at different verticals to look what we can do regarding resilience, sustainability, and competitiveness. This is, let's say, on a top level, the targets which we have, and covering different domains and looking what are shared services or common bases, how a federated data ecosystem or federated ecosystems can look like, and what is the technologies needed. So this is what we have in mind, and therefore we will setting up this initiative, and we're setting up this initiative out of Europe, but we have also a lot of links to international bodies, which I'm showing later, and we have also established a network to discuss this. And only to give you a feeling, I used some of the words, and Oscar have shown this, how the different project, and have in mind Manufacturing X is an initiative, how the different projects are contributing to this joint manufacturing X initiative. You have here, let's say, when you're going from the left side factory, is it going to the shop floor. This is exactly to look how a machine tool builder can contribute to this digital ecosystem with the DPP, with the ID management, and with the connectivity, where for sure Matthias will jump in later on this topic. Now take and laser pointer. This is more connection to the shop floor verticals. Then we have, for example, Cantera X, where we're looking really on the supply chain. Have in mind what I have shown before as example for the battery, but you can imagine when you're building a complete car, you have other tier N, tier 1 suppliers until you can produce a car and so on. Meaning that Catena X is a very horizontal, and Factory X is somehow connecting to the shop floor. Then you have several projects around robotics. For example, in the AI-based robotics, we are looking how we can use artificial intelligence really to support the commissioning of robotic systems not only in factories, because what we are doing here is, you can use a robotic system in a factory, but you can use a robotic system also outside of a factory and also in other verticals. For example, we have spoken with consumer industry, for example, when you have some goods to place in a shop, how you can doing this and how you can optimize this. Chemical is really, and behind this, sorry, I forgot this, all these companies behind by factory is Siemens and SAP. By AI-based robotics is for example, an ABB. Catena is a BMW. ChemX, which is really focusing on a digital product passport for material. It's in chemical industry, is BASF. Then you have aerospace. There's an Airbus behind, for example. Energy, there's TNET behind. David is a project, a little bit interesting name, but Matthias maybe can highlight because it's a industrial digital twin association heavily involved. And these are some kind of projects which are mainly started out from Europe, from Germany, but we have a lot of links to other regions in Europe. For example, this data for industry project is from France project, and for an aerospace are also twin projects in France and in other countries of Europe. And internationally, like you mentioned, we're setting up some kind of cooperation on an international level. Here, for example, the CSA from Oscar, the Dataspace 4.0, helped us a lot to setting this up and to establish a network. And as said before, really driving interoperability, driving also understanding what is outside, and driving also especially interoperability. As said before, that's quite important to do this. So now I want only to dig in one example and only showing you, and this is a slide I used to have one-to-one in a conference in Japan. Only seeing here one of the project I mentioned before, the factory so on the left side in the upper corner, where we are really looking how we can connect down to the shop floor. And you see here the 11 use cases, and only to give you a feeling where an DPP is important to look at it. Or, and as said before, this was done out of this presentation done at the RRI conference last October in Tokyo, in Japan. This ID management, or which is also related to the trust anchor, playing an important role. And I said before, we are looking really, besides the use cases, what could be across verticals and kernel or basic services it can look like. And for this, we have set it up, let's say, some kind of framework. By the way, this is also internationally agreed on this framework. About what we want to achieve. We're looking about also new business opportunities. We make it quite use case oriented. I have shown before in the slide some kind of use cases and where, for example, EPP and digital IT is playing an important role. We look how we can roll this out internationally. And looking what is a technology base layer, and of course to fulfilling regulatory frameworks, because it could be also in other regions comparable or different what we have in Europe, and looking what are the standards which we want to drive together. And therefore, only to give you a feeling, and I can also highlight a little bit, I've not explicitly mentioned digital IDs, but you can immediately think about versus Link 2, AAS, OPC, how we can connect, how an identity management can looking like, and now we are coming very close to digital IT, how an data space connector can look like, how an DPP can look like, and you can extend this list. But nevertheless, it gives you quickly only a feeling what we are doing. And for sure, we are building on projects which we have or which are running. For example, this O-CEI cloud infrastructure services. In here, as you know, and there was one question about the importance of edge. For sure, we have to look on a cloud edge continuum because sometimes we're storing the information on a cloud system when it must be close to the shop floor or to the processes. Then you're storing in an edge system. And by the way, to handle this is also some kind of advantage which we have out of Europe. I said before a little bit about the initiative Manufacturing X, about the different use cases, and only highlighting a little bit how it's important, how that we come to some kind of shared services. DPP and digital IT is one prominent example, and how we are doing this international is here only to give you a feeling. We set up some kind of cooperation. Started this, by the way, out of Brussels in July, and now have a setup for new countries, and you will join. Also, we are in discussion, for example, with Poland. Belgium is just missing, but is joining. We have here discussion with India and other countries, really to set up some kind of network to speak about what is needed to achieve this. Because one is clear, on the one side, I mentioned before, this global supply chains, but on the other side, you know, the different regions have also comparable demands in doing this when you're speaking with the colleagues from the industry in other regions. So this is, let's say, in a nutshell, and only to hand over to the speakers later, which may be targeting also a little bit more on an energy topic or an energy use case, in only to show a little bit here, a little bit why we have to address cross verticals, also from manufacturing, from transportation, from really horizontal, vertical aspects. Chemical, you know, is also mobility, as you see here, because when you're looking at a network, you know, factories are needing energy. Energy is produced in different areas. Energy should be distributed in an interoperable way, and therefore we have also the link to the factories or to the buildings or to the charging stations and so on. Also you can extend this picture only to give you a feeling why I was so keen a little bit also to highlight this cross-vertical cases and looking what are joint bases and how we can achieve this joint basis, having in mind that we have regional requirements, but having in mind that we have to look also how an interoperability can look like. And now I think I will hand over to my next speakers and have hopefully not spent too much time in my presentation. Many thanks.
Thank you very much, Thomas. No, you actually were perfectly on time and perfectly on point. So many thanks for having described briefly an overview of how industry is well committed with this data transparency and data initiatives with X, Manufacturing X, Energy Data X, and Cantera, and all of this. We believe it's key. And also thanks for bringing up about these battery passport ideas that I believe fit really well with comes later. So it's great to see how industrial cooperation can actually be a sparking actor and element for our technologies to take up in the energy flexibility in the industry. Exactly. So many thanks. With this, we give floor to the panelists in this session, starting with Mr. Matthew Schumann from EDF, that will talk about the demand side energy management and the flexibility in energy distribution from, well, France perspective, of course. So Matthew, if you are ready, the floor is yours now.
Yes, I am ready. I'm going to share my screen. Thank you for your introduction. Okay, you should see my screen now.
Yes, we can, yes.
Okay, perfect. Thank you very much. All right, so in these short 10 minutes, I'm Mathieu Schumann from EDF. I work at EDF for Research and Development out of Paris. I'm a researcher and project manager there, mostly working on B2C questions, but I'm going to speak also for my colleagues. I'm going to give you a panorama of problematics that we studied on the demand-side energy management and flexibility with regards to the question of digital ID management, data governance, and DLT solutions, basically. So just as a short introduction, in the global context that we know in the world today, I think it's nice to keep in mind what we are fighting for sometimes. So the climate change has strong impacts, and in the energy sector, it has one strong impact, which is the electrification for decarbonation, with an increased electricity consumption and also more intermittence because of the renewable energy sources. And for electrification, we have the development of EVs, of course, but also replacement from older heating system with heat pumps, etc. And it's important because at EDF, it had impacts because we included in our raison d'être, in our statuses, the need to fight for these things. And so it's important to have an optimized demand-side energy management to manage all this. That will benefit the grid stability, but also the end consumers on their electricity prices. So second content, so the EDF group is in the energy sector, but on the whole sector, from energy production to supply, but also act as a TSO, as a DSO, and also flexibility aggregator, etc. And so we manipulate data that is usually load curves, which are highly sensitive data. And the processing poses a lot of challenges, of course, of GDPR compliance, and also privacy and acceptance of what we can do with the data. And so a solid data governance is essential. So we need new CEI-based services to address these challenges that I talked before, but these must combine behavioral aspects and acceptance, technological automation and orchestration, and optimal placement of consumption, also with regard to the new upcoming tariff structures that I will talk about. All right, so on the topic of digital identity management, what I wanted to share with you today is in two parts. So first, the current practices in digital identity management. I have an example here of a CEI-based service platform for energy. So we have been working on a platform to securely monitor and provide AI-based services to customers. And what is interesting to see here is that it's not really DID as we want to develop it. It has been an ad hoc development where we need to make sure that we pair only one customer to one set of equipment in his home, basically. And this is done through, I would say, usual standard practices, defining ID files in a gateway-based service platform and securely pairing the ID to the smartphone of the customer. What I want to stress here, though, is that so when we do this at EDF, we need to respect a framework of infrastructure and security solutions, which was defined and which principles were derived from the French National Cybersecurity Agency. And also respecting, so basically our internal review of these constraints. So this is why I want to talk about these challenges here. So the pilots in O-CEI will be interesting because we can test DID principle and decentralized ID principle, for instance, in gateway-based services like this, to answer our use case requirements. But there are challenges for the validation of innovative new solutions like this, because we have to respect the internal restrictions that I discussed about. And also, I wanted to point out that it's important that the community proves an active development of all the solutions, standards that we are going to use, and open standards, because companies' internal review offices are going to be sensitive to that and might not validate a solution based on technologies that are not like in active development or with a big enough community. And in O-CEI, we will obviously test new technologies, first in laboratory and then on field experiments. But these are challenges for companies like EDF. All right, for data governance, I want to come back to the sensitivity of the data that we are handling. So load curves are identifying sensitive data, and we manipulate also client information. So robust data governance and data lifecycle management, it's absolutely obligatory, it's a requirement to ensure that we have data security, but also rapid responses to inquiries from data owners. If a client asks us to delete his personal data, we have to do it right away. And so in the EDF group, we decided to have a very strong and robust data governance setup here. At the group level, we have a chief data officer since the beginning of the GDPR, with records of processing activities and with an internal office that conducts analysis on cybersecurity, legal questions, etc. And this is declined at every, I would say, step of the EDF group. So for instance, the implementation at the R&D level, we have our own chief information security officer, and we also have other security officers in all our departments, processing records, and also an inter-review office. And then to ensure that all the data users know what to do, we have data catalogs, data stewards, and the unification of data locations so that we can provide a secure access to the data. So I just wanted to show this because this is essential if we want to know where the data is, who has access, and how we can delete it quickly if we need. So, but we still need to go further. So, for instance, I want to say here that we participated in the Omega-X project with the idea that we need a methodology for building energy data spaces, which was a result of the project, and common semantic data models so that we can actually share data between different industries, which is also a result here. And for energy data spaces, the idea was to have a SIM or CIM-based common data model and data transformation services to make sure that data providers could actually provide data and that the data consumers could use them even if they are part of heterogeneous data spaces.
What data do they have? They have to
all right, that was just a short part on the data models and data governance. And then I wanted to talk a bit about DLTs here in this context. The idea is that we study these questions more from an academic corporation point of view, because it's not yet a business that is easy to set up. And the big questions that we need to solve here is how to solve the privacy and decentralization dilemma. So in the past, we had a lot of projects working on blockchain, and then we also had a lot of projects working on privacy. And the two clashed a bit, and so this question appeared. And so we have different research initiatives that are done, for instance, on computer science or cryptography, with how can we create algorithms for energy services that are actually privacy preserving. Sorry. And also DLT-based solutions for transaction on energy markets that are private yet verifiable. So this is done through PhD thesis, for instance, in our stable laboratory with the Telecom Paris Engineering School. And we also have initiatives in social sciences with the question of privacy and trust in the context of the development of the blockchain. So just as an illustration here for DLT for energy transaction, in one of these PhD's work, we have the definition of basically privacy preserving auctions. The idea is that we have a blockchain-based protocol for auctions in a decentralized energy market. And this is based on blockchain, but also on zero-knowledge proofs that were talked about in the first presentation we had today, I think. The idea is that we want to prove that the transaction was done in the right way without disclosing private information. And so these zero-knowledge proofs are basically based on cryptocurrency principles, and they make sure that we can keep the bids in the auction, the participant identities, the auction results private, while showing that the auction was done in the right way. And so the transaction key in this way are verifiable and transparent. I don't have a lot of time, so don't read all the text. But still, this poses challenges for flexibility in general, because we don't want to have like imbalances due to lack of centralized coordination. So the centralization versus decentralization poses a number of questions here. We need a lot of reactivity, sometimes in flexibility, and so sometimes with this kind of systems, it can be more difficult. And also, usually we want a minimum volume of flexibility products to participate in an efficient way in the flexibility market. And so with a very strong decentralization, this also poses a lot of questions.
Excuse me, Matthew, we are a bit behind in time, so if you could accelerate, please, thank you.
Sure. Conclusion. So what I wanted to say as a conclusion here, so there are challenges for compliance validation of new technologies in bigger companies like EDF. We need to study the risk and benefits of decentralization for grid management and flexibility. There are still a lot of questions. And also what I wanted to say, because we talk a lot about technologies, demand-side energy management cannot and will not be a purely technological answer. It must be done with the customers, not against their will. We can propose as much as automation and amazing technology as we want. If it's not done with the customers and to keep them empowered with this technology, it just won't work. So working also on the social sciences part of this scope is very important. Thank you very much.
Okay, thank you very much, Mathieu, for your great presentation. I'm sure we'll have some questions later for you about your experience as EDF with prosumers and clients and consumers of the energy. Thank you very much. Now I'm passing the floor to the next short pitch in the panel, which is for Dr. Matthias Bolke. Please excuse my spelling. From Schneider, to which we talk about energy data X, relevance of data spaces in the industry of energy, which is actually to the point we are here. So thanks for accepting the invitation, and now the floor is yours.
Yeah, thanks for having me. Good morning. I hope you can hear me.
Yes.
Yes. Okay. So yeah, sending you greetings from a super nice, sunny, cold winter morning here in Berlin. And the spelling
Okay.
and the spelling was perfect. So yeah, I'm with Schneider Electric over 30 years now, more than the half of that abroad, but now back to Germany, and I'm running an association, which is and I hope you can see my presentation right now.
Right now, yes.
Which is the Industrial Digital Twin Association. So we are talking a lot about data sharing, about IDs, authentication, authorization, decentralized data model setups, and how to connect them and how to be efficient in sharing those data. And in the same time, we have started 4 years ago an initiative on the question what kind of data and in which format and in which standards we can share these data. So obviously, we are then back to the digital twin, and we have started this study and this debates with the industry. Why? Because basically 2 reasons. In the industry, especially in the manufacturing area, we are still in pole position in Europe, right? When it comes to manufacturing procedures, to machines, to software in the manufacturing sector, to all things which are happening on a factory floor, we are still leading in the world the pace. And when it comes to data sharing, well, let's make sure that we are keeping this pole position and that we are fast enough and that we are, keeping our distance to the rest of the world. And here we are in a very complicated situation, in a complex situation, because if you have a look on the industry assets, you have, the industrial assets, so the automation part, which is running the processes. On the left hand, you see these automation panels. Then you see on the right hand the process itself, and you see all the product to be produced. And here we are talking about a big complexity when it comes to data. And if you put your lens, your AR lens or your metaverse lens on it, you want to see all these assets, and therefore it's quite obvious that we need some standardization here in order to have, comparable data from these assets, and not only IoT data, but all kind of data you want to have. And if you want to run, of course, software and AI routines to optimize any kind of things, well, you need standards here. We are talking here now about energy, and it's interesting enough that when we started this work in the industry, the people from the energy departments and from the energy world are coming now to us and looking what we are doing And of course, we have more renewables now in these grids. We have decentralization ongoing. We have prosumers. We hit this just now. And this brings us a new complexity in, new dynamics, new business models. And hence what we need more transparency, of course, as well in the grids as in the industrial assets. We have an efficient asset management to do. Some of these grids are quite old, so we are renovating them. So we need in life cycle management here as well. And you want at the end you want to optimize your nets and your energy management in these nets, of course, with AI routines and so on. So guess what? The question is how to introduce here as well in digital twin and a standardized one. And the initiative Thomas just described, was one of the part of the manufacturing X is Energy Data X. So you see the consortium here, which is putting people together which are acting in those net debate and smart grid debate on transmission, but also on distribution networks. And they are now in deep in the discussion on how these portal and APIs will look like, how the sovereign data services looks like, identity and trust. All these topics we have in exchange of data are here. But again, the question, what kind of data are to be exchanged? And we are happy that this world is now coming to the IDTA and using the RS. The RS is a digital twin. I come to this in the next moment. Some academics here, if you look back on digital twins, quite interestingly, in Gartner's cycle, it was in 2018, we have seen the digital twin at the plateau of expectation. And it was said as well that in 5 to 10 years, digital twins will come to majority and then, going into profitable business world. And that's exactly what we are seeing now. Digital twins are really applied now in the industry a little bit everywhere. Not only in the engineering part, we have seen this since a while. These nice turbines from the aviation in 3D models and so on. But it's really now along the life cycle, and but not standardized yet. And so we have taken this job in the IDTA since 4 years to create a digital twin, which is basically collecting along the life cycle many different data, starting from the planning and development through the construction of an asset. Here's a robot, can be anything like a motor or a sensor or a machine or even a production line or something to produce. And then it comes to the production itself. Then you have all the IoT signals which are coming out of the asset. So this as well is, yes. Hello?
No, please continue.
Yeah, you have the IoT data, which are as well in this digital twin. So we are collecting in this RS all relevant data which you need for any kind of software, any kind of routines, any kind of optimization in order to be transparent and standardized. And we are not reinventing the wheel, where we can use existing standards on the market like OPC-UA, like Automation ML, like E-Class, like otherwise. We are using them and we are incorporating those standards in this digital twin. So the association itself is really building a global network. It's open source. We are working with an IPR, so avoid any patent discussions. We have really a very elaborated IPR in place. And we are collaborating along the value chain. We have many different companies from the different parts of the value chain. And the RS is becoming the really single source of truth, where you can find any data related to an asset or related to a process. And any function you want to play here, any optimization you want to give to the system, you're using a setup of these data, which are collecting along the life cycle. You don't need every data from this. You just need a certain setup of these data. And this setup of these data can also be standardized. And we are doing this as well. And we call this sub-models. So we are modeling for some functionalities we think they should be standardized, like, for instance, a digital product passport. We are then also standardizing these data models for given applications. So you will see later also how the RS is used in the digital product passport. We have created a dedicated website on this to show how does it work with the RS, with this digital twin. I show you here just to illustrate you the member of this association. We have people from the construction of the assets itself, like motors, motor drives, servo drives, industrial assets, because we started with industry, but also system integrator, end user like Volkswagen, or a lot of machine builder as well, and obviously also software companies. This is a fast-growing history and a fast-growing thing today. We are adding around 3 new members by month, and this internationally. So 20 nations are now on board. And as I said, this new setup, this standardized digital twin, is used not only for the industry anymore, but from the energy departments of different companies. So we are sitting together now to elaborate not only digital twins for the assets of the energy distribution and the smart grids, because you see much similarity, right, between a control cabinet for the industry and a control cabinet in an energy management system. Many similarities are there. Also life cycle management. And interesting enough, we are also now starting to see many people coming from the buildings departments. There is big international building smart organization already in place today, and those people which are in this in this movement have also decided now to adopt the RS to their needs, because in a building as well you see a lot of different assets working together, producing data which we want to use. And the most important, and I will close with this, the most important thing is, of course, as Thomas said, these assets from these various verticals are not silos. We want to connect them. We want to see sector coupling. We know that the industry is producing heat we can use in smart grids. We know that demand supply question is to create this flexibility we just heard from EDF. So we need to connect those systems between them, and it is perfect. It's just perfect if we can come with a unified standard in these different verticals. And I'm happy that what we started 4 years ago for the industry, for industry assets, is valid. I think it's because we started with the most complex system.
Sorry, Matthias, for interrupting, but we will need to move to the next presentation.
And it's funny to see, and it's good to see that this interconnectivity will come via the standard. And I'm finishing with that. Thank you very much.
Okay. Thank you very much, Matthias, for your great presentation. We are looking forward to see how this is really transferred and instilled in the energy sector. And hopefully we will be able to spark this debate later in the questions. And more focus on that, I am passing the floor to the next speaker, who is Dr. Bernard Peischel from AVL, who will talk about importance of tamper-proof assets in energy and electric vehicles in the Austrian system. So thank you very much, and the floor is yours, Bernard. Thanks. We cannot hear you if you are talking right now, but we can see your slides in the screen.
Thank you very much. I was muted. Sorry for that. So good morning, everybody. Good morning, everybody. My name is Bernhard. I'm Innovation Manager in AVL. AVL is a privately owned business here in Austria. We are mainly serving automotive OEMs with engineering services. In the business unit where I reside, it's the powertrain business unit. And today I want a little bit to talk about the role of digital assets and digital assets and transactions in different use cases that are somehow located between the energy sector and the mobility automotive sector. Let me start actually with a very basic observation, because I often think this discussion on blockchain ignores the motivation, the economic motivation of distributed ledgers. So I would like to spend one slide on very cross-functional topics and then later dive into the automotive part. Actually, when we think on the development in the history, then we saw different stages of the internet. We saw the internet of the information. We then saw the internet of things. Now we somehow have approached what we call the internet, have reached a point what we call the internet of value. Yeah. I think it's important to review that in the sense that blockchain offers new opportunities, and in a very high level thinking, we can route that back to the role of banking, that for the first time in history allowed to perform transactions and to link that to settlement. So transactions is a domain of commerce, settlement is the domain of money. And usually this has been separated, but banking allowed to bring that together. From a historic point of view, the very early, let's say, approaches to that have been natural ledgers, like for example, gold. Yeah, gold has robust parameters for supply and debasement, but it didn't move very fast, so it was very difficult to get the transaction settled. Later on, we moved to money, so essentially the world's reserve currency, the dollar. It moves much faster. You can verify it very fast. Yeah. Unfortunately, it doesn't have robust parameters in terms of supply and debasement. We are discussing a lot of inflation nowadays. Yeah. And nowadays, actually, we have approached to the point where we have created what I would call a very scarce monetary bearer asset, in terms of distributed ledger technology. And this, for the first time in history, allows us to settle transaction literally with the speed of light. Yeah? It's all notable to observe here that such kind of technologies, such kind of technological changes often affect things globally and permanently, whereas, let's say, some political decisions often have only local influence or temporarily influence. But the point that I want to make actually with this slide is here that to have a full understanding of distributed ledger technologies, I think we have to go beyond the technological aspects, distributed system, cryptography. We learned today a lot about that, but it's somehow at the crossroad between game theory, monetary theory, combined with cryptography and distributed systems. And I think mainly it's not about that much a technological change. It's mainly about a cultural paradigm shift that we have to keep in mind here. And it will have major legal and political implications because the technology, I guess, is very, very powerful, but we need to view it at the crossroads between technology and the other aspects I mentioned. Going a little bit into concrete topics, distributed ledgers and vehicle identity. We heard a lot about vehicle identity. Actually, I think what is the power of tokenization and tokens in wallets is that we can implement asset visibility very easy. So we will see we can reduce asymmetry of information via digitalization of assets. Once we have these digital IDs, each vehicle has a digital ID, we can create a kind of trust anchor. And that is, again, the basis for the various use cases. Yeah? Here you can see a map of different use cases out of the MOBI standard. That is actually quite a broad spectrum of use cases. And what also comes with the, let's say, settlement of digital transactions in this global way is that we can create a trust anchor between transactions. So we can support data exchanges between vehicle and infrastructure and vehicle and vehicle. I think what is also important to note here is that by the combination of vehicle identity, a form of trusted location, and the capability to perform, let's say, automated payments, maybe micro payments or assets with higher value, we will see in the near future some kind of autonomy in the sense of we will see autonomous economic agents that trade or perform transactions on behalf of their users. And vehicle will do lots of transactions because every vehicle in the near future will come with a wallet. Okay, that is actually a motivation of some of the use cases. We look more closer into the O-CEI project. Yeah. Here on the very right-hand side, you can see the classical automotive supply chain that, in my opinion, is more diverting into a network. Yeah. There are two wide gaps in the automotive supply chain here, actually, which I try to envision here, that there are new entrants in the automotive supply chain. Think on the renewable energy communities, fleet operators, energy suppliers, etc., etc. And we, as an engineering service provider, we want to extend, of course, our engineering services towards these new entrants. Yeah? And there are a number of use cases that we can think of and are looking into the large-scale projects. Yeah? For example, to mention here, the use case with the Austrian Postal Service, where we also look into monetization of parking vehicles. So you can think of the vehicle as an energy storage systems that can draw energy at times where the spot prices are low, and can feed back energy into the network when the spot prices are higher. But that, of course, is deteriorating the state of health of the battery. And for example, we are looking into the trade-off between economic gains and the degradation of the battery here. Yeah? Energy suppliers also need all kinds of data sharing and to, for example, to perform reactive power management, to be optimally able to provide the energy to mobile customers. And we, as engineering service providers, we need, so for example, a continuous state of health of the battery, information about the state of health of the battery, to implement things like thermal controls, all kinds of predictive controls. In summary, the point that I'd like to make here is that industry will require tools to make, for example, data attributes like state of health that have a high value, or energy demand or supply shareable in a tamper-proof and tamper-evident manner, because there's considerable value in it. And such data can, of course, be, with the help of digital distributed ledger technology, be tokenized, and we can monetize it in terms of pricing and settlements to provide it to other stakeholders, to third party in the value chain. Yeah? One of the key elements that I see in many use cases is the aspect of data sharing. Yeah? Therefore, I will just spend one slide here on the potential that we have nowadays in sharing data. Of course, distributed ledger technologies have limitations. Yeah? For example, dealing with large amount of data, you better might do that off-chain in a separated information space because you have limited number of transactions with distributed ledgers. But there are also some kind of advantages that we need to mention here. Most notable, I guess, is to mention the aspect of tokenization, so that data assets come with a price, yeah, and tokenization provides different means of finding a price for the appropriate data asset. And of course, there is the capability of not only bringing the data to the code, but bringing the code to the data. Compute to data is the word for that, actually, so that we can use blockchain technology to implement privacy-preserving technologies, like we have learned it in today's talk, for example, from EDF. I think the concept of data spaces and the concept of blockchain is somehow complementary. There needs to be a kind of separation of concerns when to use which kind of technology. For example, for efficient data crunching to implement the concept of international data spaces with a classical database in behind. And in cases where you have real value in the digitalized assets, yeah, where it needs to be tamper-proof, for example, to provide some kind of immutability for the process of auditing, like we do it in AVL for the battery passport topics, then we look into distributed ledger technologies. It is also mentionable here, worth mentioning here, that things are quite tricky in the sense that how these technologies can be intervened with each other. in a kind of complementary way. So, for example, there have been early minimal viable products that implement the data spaces concepts with permission distributed ledgers. But on the other hand, we have also seen some use cases where, let me say, we use the decentralized IDs that the blockchain technology can provide in order to provide identities to the database protocol, or also the implementation of usage policies, which are, for example, specified in the databases protocol or in the base databases framework, to be plugged into the implementation of these policies as smart contracts. So it can, for example, can these policies be implemented in terms of smart contracts, and we can then plug in the smart contract into the international databases framework. So there is kind of complementarity, but one has to know when to choose which technology, because there are different virtues and different limitations. Yeah. To finally conclude on my 10 minutes here, I would like to make maybe a short summary. First of all, I tried to motivate that distributed ledger technologies are mainly a cultural and not so much a technological change. Yeah, very good understanding of the economic perspective is, I think, very important to bet on reasonable use cases that we can scale. I also argued that via a combination of digital vehicle identities, trusted location, and the capability to do transactions in the sense of payments, we will see in the near future autonomic economic agents, and they will spin up lots of potential business cases. Yeah. I also pointed out that data sharing is an enabler for all these use cases, and that you can do this via classical data spaces or with the new blockchain technology. One of the key elements was here that to have a tamper-proof way, or to have the need to have a digital asset in a tamper-proof way, is to increase the trust. Yeah, and this is inherently linked to the process of settlement of transactions as a digital bearer asset finally. And basically, I think we need to understand that data spaces and distributed ledger technologies can complement each other, but it is a bit of an open issue, particularly on the economic value. It's not so much about the available technology, but clarity needs to be provided with respect to where is the economic value of distributed ledger technologies compared to other data sharing aspects. Yeah?
Okay. Yes.
Thank you very much.
That's great. Thank you very much, Bernard. I'm sure we will have some questions for you later, so please hang around after the next presentation, which I introduce right now. It's Dr. Max Helmich, who will introduce asset administration shell. Please, I kindly ask you, Max, to be as quick as you can, since we're a bit behind the schedule. And please try to be strict to the point of decentralized ID, energy, and DLT, which are the main topics of this workshop. Thank you.
Okay. Thanks a lot, Nacho, first of all, for the invitation. I will go down the route of Mathieu and Matthias, kind of in a mix, because my background with Siemens is from the energy sector. Therefore, today I'm speaking for T&D Europe on the concept of asset administration shell and how we can use the asset administration shell in our world, basically, to onboard assets. So first of all, why the asset administration shell? As Matthias has also mentioned, at the moment, it's really complex to onboard assets, flexibility assets in particular, to grids, for example. Therefore, we got high commissioning costs. We need to source our data sometimes from PDF documents or printed out documents. And therefore, we've implemented the asset administration shell as a technical solution, which is an open source framework. It's basically the single source of truth, as has already been mentioned by the IDTA. It's standardized, and for us, this is the biggest point because we can really engage seamless interoperability. So if we've got different manufacturers within an energy grid, which is quite common, different vendors got their own setup, but in the end, we need to harmonize data. We need to harmonize value sets so that we can set up one digital grid, for example, for a smaller community, so that this community can act as a prosumer community, for example. So therefore, we need to standardize and harmonize data. And in your case, Mathieu, what you've mentioned, of course, we can also act on restricted models, because you mentioned that the data that we're looking at, especially load curves and so on, are really sensitive data. Therefore, within the asset administration shell, you get different kind of submodels. They can either be public or restricted, and therefore, when it comes down to data security and cybersecurity, we can always restrict submodels so that only limited people can access that data within that submodel. How does it look from our perspective for the DPP 4.0? That's the case that I'm highlighting today. As we've already learned in the morning, the DPP stems from the Eco-Design for Sustainable Products Regulation. Therefore, the DPP will be in place. In our scenario for the grid, what we've set up in Germany with the EI in Germany is a showcase around the DPP 4.0. Maybe let me get the laser pointer, then you can see my mouse for the DPP 4.0. So there we are highlighting how we can bring in different vendors of an asset into one asset administration shell and therefore into one use case. Therefore, we are using the DPP as the foundation, so to speak, to get the people on the digitalization track. The asset administration shell is our vehicle to collect data, to retrieve data, to interchange data, therefore the harmonization. And of course, as said before, we've already implemented the authorization for different kind of submodels. Within the DPP, what we've set up is a so-called digital nameplate 4.0. On the next slide, I will show you what this looks like. And as Matthias has already mentioned, to fulfill the DPP, I need information from different kind of submodels. So I could, for example, jump into technical attributes or environmental information, circular economies, and so on. And all these informations I can simply pick out of these submodels, and therefore I can build up the data or value set that I need for my use case based on harmonized submodels. And therefore, I can really plug into data streams from different kind of vendors. And for us, this setup enables us within the DPP 4.0 or the asset administration shell in general that we can basically create different kind of submodels for any other digital services, for any other use case that we want to highlight. So it's basically like a Lego box. So we can build up bricks, and in the end, we will end up with a full cluster of full digital twin of any kind of grid part, for example. And therefore, we can implement such things as the SIM, BIM, E-class, whatever you basically want to go for. The asset administration shell is that flexible that we can set up these submodels or ontologies into one data source, essentially, which is a really big benefit in our perception. For the digital nameplate 4.0, which is part of the DPP 4.0, what you can see over here, we've basically got a value set. This value set must be defined or must be harmonized between users, vendors, manufacturers, etc. And therefore, in the end, we set up a submodel together with the IDTA. For example, you can see a few variables or values like manufacturer name. I mean, it's pretty straightforward, contact information, etc. And this is then bound as a submodel within the so-called asset administration shell for a product. And then if you want to retrieve this information, you can basically scan a QR code, receive the information through an asset shell viewer or through a web page, and there you would basically plug into the submodel digital nameplate and retrieve all the information from these values. I can show to you how this looks over here on the next slide, you would basically go ahead, scan a QR code, and if I open this one, for example, up in an asset administration shell viewer, what you can see over here, I've scanned a CPU, and within the submodel digital nameplate, I can build up all this information that would normally be on the CPU, basically printed on the CPU or in a manual PDF document and so on. So for example, if you scan the QR code over here, you will end up at the product page where you can find then the asset administration shell. So if you're keen to test it out, get yourself from GitHub just the asset administration shell viewer, and you can retrieve all this information and can take a look at the digital nameplate, how this would look like. So it's a real benefit for us. There's only one QR code basically, and we can plug in as many submodels as we want, so that we can really bring across a vast amount of information. And just to sum it up, because Nacho said we need to hurry up and get time back. So what is my end message? Basically, as we've set it up beforehand, we've got different value sets, for example, the DPP or flexibility use case that we are discussing at the moment also with the EU together, or we can basically create a generic use case in the end. We will end up with a value set within a submodel. We can plug in the values that we need. And as the end result, we've got an asset administration shell, for example, for a product, for a production line, whatever, with different kind of value sets behind for each of the use cases. So therefore, as Matthias has also mentioned, it's really appreciated to use the asset administration shell because it's a vehicle for us to plug as many information as we need on a product in a harmonized and standardized way. And it's open source, therefore it's really flexible. We do not get any lock-in effects, whatever. And therefore it's really appreciated to go with the asset administration shell from my point of view. And Nacho has asked about data, cybersecurity, and so on. Therefore, again, I would like to highlight, we've also discussed about EIDA's access control for these submodels, and we will go down this route as well. So please keep in mind, we can always restrict informations within the asset administration shell. And with that in mind, I would say that we retrieve back a few minutes. If you've got further questions, of course, you can contact myself, or for TND Europe, you can go for Federica in this scenario. Thanks a lot.
Thank you very much. Thanks a lot for brevity and conciseness, Max, in your presentation. That was very appreciated. So now we have just around 10-15 minutes for some questions we could have for these industry panelists and speakers. And I would like to start to see if you would have any kind of questions here, Thomas or Rolf, before we go to the list. Or
yeah, I may have a question to Matthew, because you mentioned that you work on a gateway with a secure pairing. What sort of devices are you thinking of which should be paired to the gateway, and what sort of standards are you looking for?
Sorry, I was unmuted. Now you can hear me, I guess. So
yes.
So we have two types of equipments, because we have EDF subsidies who work on their own material that is already offered to customers. But I would say this is more like a proprietary object. And that R&D in the framework of European projects. So basically we work on specifying gateways based on material that is easy to use. So and also we want to be compatible with open protocols like Zigbee and Matter. So basically this development is very strongly linked to our actions on Matter. And yeah, because we have, I would say, requirements internally to be as auditable and open as possible. So we try to avoid using too much proprietary or non-standard protocols or way of doing these things. So do you have maybe a more specific questions on the gateway itself? Or?
I think that was my main question about that we see trends in the gateway that you separate the interoperability, which is Matter, from the service domain, which is also Meta as an enabler, but Meta not doing the service themselves. So I think that answers my question.
Okay.
Okay, that's great. Thanks, Rolf and Mathieu. I would have one question, which was kind of for the rest of the panel, but mainly from question from Matthias, about why do you think a reliable, traceable energy accountability using DLT and data sovereignty tools would be important for the industry, like fostering confidence in what is stored there?
Yeah, well, I agree, and I mean we have many debates about this identification, authorization, and so on, and all these topics are around now. But listen, what I think is, and the question is really, you know, where to put this and where to, you know, have an orchestration about. And maybe the answer is not yet on the table. But what I would like to emphasize on is let's start now with some real cases. We have now, you know, with Confinity, we have an association which is now running first data space setups on the market. We have other sandboxes which are now, you know, starting to show how actually this works. And here we see all kind of experience popping up. First of all, for sure, you know, how efficient these things are, how performant these things are really running. We are scaling them first small, then larger. So we need experience in this, but nothing prevents us now, you know, to go forward and to start and to make these tests. And I think with these experiences, we will come up with a very interesting set of know-how how to go forward. So we have many discussions, many debates. Yes. I think it's really time to go now and to try out several dispositives which we have in the energy departments you have seen, but also on the industry side. We have now some OEMs basically sitting together with their end user, and they are, you know, going for real use cases. And we are building now sandboxes where you have decentralized data spaces which are sharing those data. And then all the question you have, but any other question about decentralized data spaces, we will see and can judge them and can for. So my suggestion is go for it.
Okay, great conclusion. Thanks, Matthias. Yes, Thomas, I know you have your hand raised, but since my next question is also for you, I take advantage of this. So I have a question which is both for Thomas and also for Bernard, because both of you mentioned a concept that has been mentioned several times today, which was trust anchor, to serve as an element that could sit on top of the global verification of the process. But I guess that from technological and conceptual perspective, I have the following question, which is, on the one side, we want decentralization and DLT to not rely on centralized entities. But at the end of the day, we are suggesting still to keep this trust anchor element. So how do you see this fitting? Because it could seem kind of contradictory. And I would like to know your opinion here.
Matthew, will you start or should I start? As you like.
Yes, Thomas, please you start, and then I will pass.
Okay, first of all, it was my topic why I raised my hand before, only to second Matthias, and you have smelled this, all the use case, all the projects, you see this, the X projects have concrete use cases. And that's the reason, only to second what you said, just do it, prove it in the reality. Regarding the trust anchor, and you know, we have also on the international level discussion how decentral it could be done or how central it could be done. You know, we are just starting the discussion, and Oscar, you know, also as a topic to build up an framework which for sure have to act decentral. Sorry, no, I got the word decentral and international. But to allow local plugins. I'll give you an example. When you're speaking with Japanese people, they have maybe a complete other understanding and maybe a complete other regulations which we have to fulfill. Also we're working really on a framework where you can plug in some maybe regional aspects. And with this framework, you get it some kind of interoperability and flexibility, and let's say also decentralization if needed. But Oscar, if you raised your hand, maybe you can add.
Yeah, no, just to comment a little bit on top of what Thomas is describing. The question you ask, Nacho, is difficult to demonstrate at this point in time. But the only thing that I can add from the Thomas answer is that we need to make sure that we fulfill basically two missions. One is that we bring our European standards, the ones that we are building together, and then we can build with some level of decentralization here in Europe. But we have to be aware as well that the ID management technologies that we select for our European solutions will interoperate with other ID management solutions that will be implemented not only in Japan but also in the States or countries like China. And I think to think on a fully decentralized solution, at least in the area of industry and energy, it could be difficult to accept, not to implement technically, but to accept from the business perspective and from the data governance perspective, because there are some things that I think need to balance the complete distributed DLT solution with the data governance. So probably data governance will have something hybrid. And then inside your own domain, then you can actually implement this sort of more decentralized solutions. We can rely on EIDAS and this type of technologies for ID management.
Great. It is great to remind the frameworks that are there that we should comply with. But coming back to my point question about the discrepancy about the trust anchor and no trusting in DLT, Bernard, if you would like to add something since you have this hands-on experience, thank you.
Thank you. Yes. So maybe I'm thinking in that direction in two very extreme pillars. You can have very completely decentralized systems and you can have fully centralized systems. Both are at the end of a spectrum that are, let's say, in terms of industry, it's not very likely that you reach one of these spectrums entirely. So the things that I have seen is that there is, depending on the value that you transact, there's different needs of decentralization. And therefore, I think the aspect that Thomas mentioned and also Oscar mentioned, being interoperable is very important, because in a realistic use case, I think we might most likely see a combination of very decentralized trust anchors and centralized trust anchors in realistic use cases. It just I give you an example. If you look at the scale up of Catena X now, the identification aspect is still quite centralized. So I have to develop trust into a third party, which, given the business relationships that we have, actually we can do in the automotive industry. And if you look at systems where we transact more, let's say, valuable assets, and it's about the transaction of values here, then you might switch to more distributed identification. But I think it's very important to have this kind of interoperability between the different systems. I also mentioned in my talk that there have been attempts to integrate distributed IDs into the databases framework that currently into the data spaces framework that can be implemented also as a centralized trust anchor right now. And I think the different sectors and the different verticals that we have will converge into less or more distributed or more or less distributed approaches with different speed. And I therefore think the aspect of interoperability is very important, because we need to implement or enable use cases that go across different sectors. For example, the ones I motivated between energy and mobility sector.
On mobility. Yeah, thanks. I like this answer very much, Bernard. Like, depending on the use case, we might like these trust anchors to have more protagonism or less. And I am looking forward in the future to see it. Do you like to say something?
Yes, I have questions. I'm Pierre Marot. I'm working the same directorate as Rolf and Thomas, but recently on the blockchain file. And just to illustrate this discussion, I see in the last presentation a reference to a digital nameplate. And I think it was by Max and Bernard refer to digital identifier, decentralized identifier, the idea and this model of W3C. So just to elaborate a bit more about what has been said, can you explain the link, or if there are reflections to link the two together, or if they stay a little bit under different separated model?
Max.
Okay, so first of all, what I highlighted on the digital nameplate 4.0 was basically the general approach of a digital product passport. So information that is normally stored either on the asset or in the PDF document could be highlighted in a digital nameplate. And you were talking in the direction of Web3. And within Web3, of course, you can use the asset administration shell as a basis to exchange data. So I guess it must be aligned. The naming must be aligned of different value sets. That's true. So that we got one foundation that we know that everybody's talking about the same point there. And it could be that within our approach for the DPP 4.0, there might be overlaps with different kind of definitions for the digital nameplate. That's totally valid.
Mm-hmm. Okay. Thank you, Max. Thank you very much. Now that we are a bit behind the schedule, but still I would like to spend 2-3 minutes and give the floor to Maria Jufrida, which is connected online, because in Slido app, which is running in parallel to this session, we are having some reflections and questions. So if you want to spend only 1 minute talking about that, Maria, this would be great. Thanks.
Yeah, I will do it. Miss Maria is now busy, but I can do it. Can you hear me?
Okay, Veronica.
Okay. So yeah, we've shared in the chat the link for the Slido. So I hope you've seen it. I can share the screen. So 1 moment.
If this is brief, yes.
So can you see my screen?
Yes.
Yes.
Okay, so here we have the questions from the first one. So we already got some replies. Okay, do you want me to go through all the questions from the first one?
No, let's not do this then, Veronica, in this way. Just I kindly ask now the panelists here in this last industry panel to switch to slide if you have some time, and be so kind to reply this shortly, even via text, so that everybody can just hear from experts in the matter. In the meantime, we will advance with the session normally. So, but before that, I would like to thank all the panelists here for the great discussion, the great presentations. It's always a pleasure to have such top companies speaking to us, especially for us academic people. It's a complete honor to hear you, and we will hope to be aligned in the innovative pilots to be developed in O-CEI in the next 3.5 years. So many thanks, and I will see you around. Thank you for this.
Thank you, Nacho.
Great.
Thanks.
Thank you.
Thank
Thank
you.
you. Bye-bye.
Thank you.
Great. So now trying to close the circle, since we had the presentation from the Commission, the first panel about specific technologies and ideas and challenges. Now the perspective of industry had come into place. And for kind of closing the last session of today's workshop, we have a bit of broader perspective coming from relevant clusters, initiatives, synergies with different sectors that come into play. And here in particular, we've turned the focus into more the technological cloud edge perspective with a presentation from Mr. Madeleine Neag, which comes from Open Nebula, who is a European actor, which is playing a role in the edge, cloud, open initiatives in cloud, also projects. and also with commercial products. So we believe it's a perfect match and merge between what we are talking. So I would like to start this session about related technologies with his presentation. Magdalene, I pass you the floor. I kindly ask you to focus into the topics of today and to link as possible everything you will say to decentralization, energy, and your application of the technologies from O-CEI. Therefore, please, the floor is yours. Go ahead.
Firstly, Nacho and all, thank you very much for having me here. It's a privilege to be among you. And until now, everything has been so rich in information. And yeah, I'm happy to be here to talk about technological base layers. I hope you can see my slides. I hope you can hear me.
Yes.
Today, I will try to present briefly about the synergies that we can create with O-CEI SYS architecture and Virtuora integration framework. I split my presentation in 4 items. I will have a short introduction about Cloud Edge and IoT. I'll talk more about O-CEI SYS and how this is enabling the subjects about which we discussed today: distributed ledger technology, digital ID management, and data governance. I will introduce also Virtuora, and after that, I will do a parallel between O-CEI SYS and O-CEI. Yeah, we know that edge computing, or better said, Cloud Edge Continuum, represents a fresh opportunity to meet the demand for next generation data processing infrastructures. It helps also in the investigations for suitable network architectures and control mechanisms to handle the processing of massive data in secure and private manner. Through that, we can address latency, security, privacy, and environmental needs. And by combining federated learning and homomorphic encryption, we can allow organizations to glean insight on their customers without hoarding personal data. We know that there is a need for end-to-end intelligent enablement for the orchestration of the data, computing, and AI capacity across the Cloud Edge IoT continuum, but also for DevSecOps or SecDevOps to ensure data confidentiality in the Cloud Edge continuum. And this is where O-CEI SYS arrives in the picture. Back in 2020, 27 EU member states signed a joint declaration on building the next generation cloud for businesses and the public sector in the EU. The EU has a unique opportunity to address the need for more data sharing and decentralized data processing closer to the user at the edge. Through that, we will enable multi-provider Cloud Edge Continuum. We will try to strengthen the EU digital industry, but also we will try to develop the biggest European open source project and implicitly the European open source technologies. O-CEI SYS is mapped or is split into 4 work streams. The first one handles the Cloud Edge Continuum. The second one handles the Cloud Edge capability, including here the federation and multi-cloud, everything as a service layer, integration, monitoring, management and optimization, operating systems and virtualization, technical requirements and architecture, but also cross-cutting aspects like security and sustainability. Workstream 3 handles the smart advanced data processing, and workstream 4 the use cases. If we look at the use cases from O-CEI SYS, we will see a very big resemblance with the use cases that we have in O-CEI, and this is why it's very easy to map them there. Looking closer to O-CEI SYS, this is how we are trying to feed these capabilities into the use cases and at the end in the end users, combining Cloud Edge Continuum with Cloud Edge capabilities, and in the end with the data processing services, we help the use cases to be created, to be enabled, and in the end the end users to benefit from those. Regarding cross-cutting aspects, because here I think we are closer to the today's subjects, we have cybersecurity, energy efficiency, and interoperability. And by that, I mean that in the cybersecurity layer, we will need to develop the advanced cybersecurity services by incorporating AI-based approaches, and also to create or to manage interoperable telco edge workloads, to create solutions for secure control and data transparency, and also for having security components for composable data transfer services. In energy efficiency, we need to be able to monitor the interoperable telco edge workloads to enable energy optimizations. We need to create advanced functionality for energy usage analysis and modeling across the telco cloud edge continuum, and to have AI solutions to optimize energy efficiency of data processing. And of course, interoperability, because that was a thing that was mentioned multiple times already, to have open reference architecture for the multi-provider cloud edge continuum and business interoperability. Looking at the state of the art, we see that we have cloud edge hybrid architectures, but mostly are based on proprietary complex technologies leading to vendor lock-in. And we have centralized cloud structures that assume highly homogeneous data centers. In regards to multi-provider interoperability and portability, we see a low adoption of the standards with abstractions layers based on containers with reduced security. Storage and network model are not well suited for highly distributed cloud edge continuum. We have only partial use of automation techniques, and we notice also lack of specific edge node architectures. In terms of multi-cloud management and orchestration, AI is not so much used. We have centralized control planes that do not allow the federation, and in the same time limited support for optimized orchestration, energy efficiency, and enforcement of security policies. For the use cases, we see that we have deployed our use cases are deployed as static solutions on a case-by-case basis, lacking automation, interoperability, and portability. In terms of future trends, we see emergence of new edge providers, including here EU's intention to have up to 10,000 neutral edge nodes by 2030. We need complete automation for cloud operations. We see new security threats, a larger impact on vulnerabilities, the preference for energy efficient nodes, but in the same time, widely distributed environments, the need to have ecosystem integration, linear data storage and collection, and another need, which is the one for interoperability. Virtura is an integration framework resulted from IPSIS's workstream 2, and practically is a cloud edge infrastructure testbed combining bare metal resources from 8 IPSIS's partners across 6 EU member states. Its purpose is to provide a space for the integration of different virtualization components and relevant use cases, and is based on sovereign open source and software stack. You have more information in the press release related to that, and also on the YouTube video about it. Closing the loop, I'm coming to Cloud Edge Continuum, which practically is the foundation of Cloud Edge IoT and the enabling layer for all the technologies that are discussed today. We need to have integrate end-to-end capabilities such as processing, storage, connectivity, computing, sensing, intelligence, security, safety, and privacy. We need to enable value creation via the provision of platform and application of services across EU. Cloud Edge Continuum resources will need to support IoT edge capabilities and intelligence, and represents the technological basis for the initial rollout of advanced data processing capabilities for key sectors. In the same time, it can ensure the distributed end-to-end security technologies supporting their complex behavior and data sharing, but also can enable the development of European DLT services following the model of EBSI, which is highlighted here on top right. We consider also the distributed nodes across the edge to cloud continuum as the foundation layer of this framework, of this architecture. And of course, for our project, it will represent a very big benefit to make it compliant with IPSIS architecture, because IPSIS is building technology components to cover the gaps IPSIS will facilitate to reach the digital compass target of 10,000 climate neutral, highly secure edge nodes deployed across the EU. It will help to build the solutions to provide HPC services distributed across the cloud edge continuum. It will accelerate the cloud edge uptake among SMEs, strategic industries, and public administrations by addressing emerging data processing demand, and also it will foster the EU global technological leadership in the cloud edge sector. And this is why I said that it will be a good advantage for us, because O-CEI blueprints can adopt IPSIS functional components, interfaces, and open source technologies already benefiting from interoperability and exploitation. It can help avoid duplication of efforts and in the same time promote the active involvement of the broader EU industry in the long-term improvement of the O-CEI blueprints and in the project's use cases.
Thanks, Madeleine. I think we can wrap it up if you're able to. Okay.
Thank you very much for your time, and sorry if I passed the time that was allocated for me.
No, it was fine. Thank you very much, Madeleine. Since we will not have a panel later and we would like to focus on specific presentations, if anybody has any question for Madeleine, maybe we would have 1 minute now. Anything here, or it's clear? Okay. Then I think we can pass to the next one. Thanks, Madeleine. In case, hang around if there are any questions later. So
Thank you very much.
Yeah, great. I will pass the floor now to the next speaker to present about the connection with IDSA, GAIA-X, and the Tangle integration, who is Miss Angelina Kovac from Ikerlan. If you are here, Angelina, I will just pass you the floor now.
Hello, good morning.
Hello, we can hear you now. Yes.
I'm currently trying to load my presentation. So
okay. We can hear you now.
Okay.
Okay.
Okay. So
yes,
if you can see it, okay. So first of all, thank you for having me today. My name is Angelina Kovac. I am a PhD student and researcher, currently working on cybersecurity on data spaces. I am pursuing my PhD on Ikerlan, which is a technological research center located in the Basque region in the north of Spain. And well, in this presentation, we are going to explore how distributed ledger technologies, specifically DAG-based distributed ledger technologies such as the IOTA Tangle, can be integrated within the data spaces architecture. And for that, I'm first presenting you our proposed solution for this integration, and then we will end up with some final conclusion remarks on how these technologies and all of the technologies seen during this morning can enable and enhance data spaces. So to begin with, let's imagine we are a data owner and we have different industrial machines in different industrial data, generating vast amounts of data. And we first want to store the data in a data storage system. But then we may think on how to explore or how to get value out of that data that is that we are not initially using that data. So for that, we may have an external data user or an external entity who is interested in using or processing or analyzing that data in order to enhance its own industrial processes or to perform maintenance analytics. In order to share our data with that external entity, we have some requirements that need to be met. First, we need to have secure data exchange across multiple entities across domain. We need to ensure data sovereignty, and for that, we need to make sure that we, as a data owner, we have full control on with whom we are sharing the data, how and under which circumstances, right? So for that, we need to have data access, we need to have also control on how data is used, and we have to follow legal compliance. So to meet those requirements, we can make use of data spaces. That is some technical infrastructure that enables us to share data between different stakeholders within a common framework of sovereignty, trust, security, and governance within the key pillars of interoperability, sovereignty, and value creation on top of these infrastructures. So in here, we are basing our solution on the International Data Spaces Reference Architecture under the 4.0 version. And here we can see the conceptual definition of the different core components of a data space. To begin with, we have the connectors, which are our gateways to enter the data ecosystem, which will perform most of the core processes needed in the data space. But then we can also have or may have other necessary components, like the identity provider, which in our case will help us identify, authenticate, and authorize the different participants and technical components of the ecosystem. Then we will also need a metadata catalog, where the descriptive metadata, features, and usage terms of the available data assets in the ecosystem are kept. And then finally, we will have some sort of clearinghouse, which will be in charge of recording all of the operations happening in the ecosystem. So our purpose is to implement all of these core conceptual components of a data space with the help of a distributed ledger technology. And among all of the different types of distributed ledger technologies, we have based our solution on the IOTA technology and its distributed ledger technology, which is the IOTA Tangle, which is based on a directed acyclic graph structure where incoming transactions are the ones confirming the transactions that are already in the ledger. Because of these specific structures, it is suited for industrial IoT environments because it will enable us to have microtransactions and scalable solutions built on top of it. And as a distributed ledger technologies, this enhances the data space with data immutability, data traceability, and data
From Cantabria
provenance.
region.
No, but I mean,
Yes, from the Cantera region.
Please continue, Angelina.
Okay. Yes, as I was saying, and more specifically on our solution, the IOTA Tangle facilitates us to have a decentralized identity management, serves as a verifiable data registry, and enables the deployment of smart contracts to automate different processes happening in data space. Okay, so now going on with our proposed integration, at a more technical level, we will start with the connectors. So our solution is based on the Eclipse data space connectors deployed as Docker services and implemented in the data space protocol. As for the distributed ledger technology, we are using IOTA Tangle, and we are deploying a private IOTA Tangle under the Stardust version, and we are using one for the control plane of our data ecosystem, but we are also, we have decided to use it for the data plane to actually store the data that is going to be exchanged. So, okay. Next, to better explain our solution, we will have a look on the different processes defined for a data space based on the International Data Spaces Reference Architecture Model specification. So the first one will be the participant onboarding. That each participant in the ecosystem must be identified and authorized to ensure trust in the ecosystem. In our case, we are implementing a decentralized identity management based on the self-sovereign identity concept with decentralized identifiers and verifiable credentials. And we are making this with the IOTA Identity Framework. Then, as data owners, we want to publish all of the descriptive features of the offered data. In our solution, we're making it with a verifiable credential that encapsulates the metadata description, usage policies, and for example, different terms, such as the pricing, we are willing to be paid for the use of that data. So that verifiable credential will be stored or kept in the metadata catalog. And all of the operations happening in the data ecosystem are kept on the IOTA Tangle via the clearinghouse component. And now on the other side, where we have our data user interested of acquiring or using our data, the data user must also be identified in the ecosystem. And once identified, he will query the metadata catalog for the description of all of the available data assets in the ecosystem. And once again, all of the operations will be stored once again in the clearinghouse. Now,
sorry, Angelina,
yes,
if we can speed up a bit the flow, we will appreciate it.
Yes, okay. So once the consumer finally selects the data he wants, the actual contract negotiation process will happen between a data provider and consumer connectors. For this, the Eclipse Data Space Connector currently do not have this process completely implemented. So at the moment, the consumer has to accept the usage policies and terms defined by the provider and cannot make counter offers. To solve this, we are currently working on a semantic engine based on this proposed workflow, where we allow the definition of threshold values attached to the contract terms of a data provider. In this case, the data consumer can actually make counter offers to the contract terms, and the engine will iterate on it until reaching a contract agreement between both stakeholders. So once we have a contract agreement, the actual data exchange can happen. To this process can be implemented between connectors or in any other method specified in the contract agreement. But in our case, as we are using the IOTA tangle also to store the actual data, our data consumer has to access the tangle to retrieve that data. However, we have to ensure that the consumer is using the data according to the access and usage policy specified. That is the process we call the policy enforcement. So in our solution, we have to monitor the usage of the data and notify in case the policies are not being met. For that, we need a policy enforcement mechanism. We are currently working on with implementation of different usage control tools that can be integrated within the data spaces connectors and exploring the use of private enhancing technologies that will ensure data privacy even when data is transferred. So that will be all for the proposed solution. And now as conclusions. So we have demonstrated how IOTA technology can be used to implement core data spaces components, and more specifically, how distributed ledger technologies can be used or applied in data spaces. So they can be used for being or for implementing the identity provider for data space. That is, providing the decentralized identity management based on self-sovereign identity. It can be used on the metadata catalog for having a registry of all the available connectors and a list of data offerings with its descriptive features. That is for storing the verifiable credentials and verifying those verifiable credentials. As for the clearinghouse, we can use it to monitor, to store transaction states and policy enforcement, because it will offer us to have immutable records stored in the distributed ledger technology. It also enables us to have smart contracts that will enable automated processes, such as the contract negotiation and compliance enforcement. And we can also have wallets on top of the distributed ledger technologies that will enable us to have secure and automated payment system within the data space. And that will be all. Pretty brief.
Great, Angelina. Thank you very much for your very, practical and step-to-step flow of integration. I think this is enlightening for us to see how technology can actually be applied and to see private companies that are, investing time on doing so. Thank you very much, Angelina, and please remain around in case there are other questions later.
Thank you.
Great. So continue with our last session. The next presentation is to be done by Mr. Mario Petruzzella, coming from ARSYS, and now from another angle, leaving aside a bit the smart contracting and the decentralized tangle and DLT, moving to verifiable credentials as well. We have already had certain presentations this morning touching upon this topic, but we hope to have more also practical view on the technology about it from ARSYS. And before passing you the floor, Mario, again, I ask you for brevity with appreciation beforehand and go straight to the point. And many thanks, and go ahead.
Okay, thank you, everyone. Good morning. Hopefully you can already see my screen.
Yes, indeed.
Okay, so yeah, I will try to keep it short, Nacho. Also because Annelina already introduced some of the key concepts I wanted to talk about. Okay, so yeah, we are going to talk about the role of verifiable credentials in Gaia-X data sharing ecosystem. Okay, just a little about Tarsis. We are a Spanish company based in the north of Spain, in Logroño. We provide infrastructure solutions and also services that help our customers in their present in internet. Okay, mainly services related to cloud and different solutions. We are also part of IONOS Group. And in the innovation department where I work, we have been working with many innovation initiatives over the last year, maybe related to data sharing, among them Gaia-X, IDSA, and Business Data Value Association, and many others. And we also have quite experience in other projects related to different innovation technologies and funded by the European Union. Related to Gaia-X, we have been working for the last 3.5 years, more or less, for 4 years. We take part in different working groups. And in short, what Gaia-X aims is to define a federated and secure data infrastructure where the sharing of data could be done in a trust and secure way. In short, there are 3 main pillars or work streams that establishes the common rules of behavior to generate this trusted environment in which data can be shared in a safe way. Depending on its objectives, each pillar implements 2 kind of specifications, functional and technical, that are translated into different software components that we will see later, check the requirements of participating and working in a Gaia-X data space based on. These 3 pillars are a federation that facilitates the secure and reliable exchange of data and services, not only among the members in the federation and data space, but also, as some colleagues have already talked about, in order to gain or to ensure an interoperability among the different data spaces that are going to be built. Okay, the compliance pillar that establishes the mechanisms to ensure that participants in a data space are really fulfilling all the requirements they are supposed to do. Okay, and the data exchange that provides the means to carry out the data exchange itself and keep records of the negotiation data in the infrastructure layer. The trust framework is the common concept in Gaia-X that collects the evolution of in these 3 pillars. Okay, the functional specification describes concepts at a high level. These functional specifications are translated into technical specifications, and according to these technical specifications, different working groups within Gaia-X implement software artifacts that execute at the infrastructure layer, offer the needed functionalities to work in a Gaia-X compliant data space. This common way of working for the trust framework is the use of verifiable credentials. Okay, it's a mechanism to achieve or that collects all the developments and deployments that are done in each pillar of Gaia-X. At the end of the day, a verifiable credential is also a standard defined by the World Wide Web Consortium, and it's a set of claims signed by you and trusted and validated for a third entity accepted
for all the participants in the data ecosystem, okay, which provides this trust or environment, safe environment where data can be exchanged. According to Gaia-X, there are two kinds of verifiable credential: participants and service offerings. Okay. The participant, Annelina talked about this. There are many different roles in a space ecosystem. Okay, we just want to focus on these two. A provider, that is the participant that is going to provide some kind of service offering to the ecosystem to be consumed by the rest of the participants. In this case, of the consumers. Okay, but the most important part here to take into account is that each participant needs to have its identity card, so to speak, its verifiable credential that identifies him or her in the data sharing ecosystem. Okay, the other type of credential is a service offering. A participant offers something to the rest of the data space members. And also, this service offering needs to have its own verifiable credential. It contains some kind of basic attributes to describe what the service contains and what is being offered to the rest of the participants, and also provides information of whom is providing that service. In short, this would be the way to build a credential for a participant. We need three different ones: the legal registration number, some claims related to the terms and conditions, and some claims related to the information about the company. This is needed to be signed with an extended validation certificate to provide trust in an environment. Then we would build a verifiable presentation that checked against the clearinghouse, that are the software companies we have been previously discussing, would check that the participant credential is properly defined and contains all the information it should. The service offering credential more or less has the same structure, but adding the service offering claims in this case. Okay. So what does a clearinghouse in the context in Gaia-X? It's different from the one Annelina was talking previously. These components are the result of the work that is done in the working groups in Gaia-X. Okay. We are in Narcis. We are an official provider of the clearinghouse, and in short, they are the services that checks that all the credentials are valid to provide this layer of trust that we have been discussing. They check that the certificates that have been used to generate the credentials are valid. They checked that the information that the claims contains hasn't been tampered since the time it was signed. The information that the credential has to contain is also relevant and according to what Gaia-X specifies, and other kind of rules as validation of terms and conditions, the legal registration number of the company, and some other checks. And I think that this was my last slide. Hope more or less to have put some light in the way that Gaia-X works. In any case, feel free to contact if there are further questions, and we'll be happy to answer if possible.
So I know there is another ongoing project in parallel to O-CEI that will also be exploring these terms. So either from my side or from the other, we will be looking forward to see how this materializes in real practical deployment, right? Because we have now seen the perspective from this blocks diagram and these definitions, and we hope to see this put in practice very soon in the innovative projects and actions. Anyway, thank you very much for your intervention. Great. So just to conclude our set of sessions and set of presentations. We would like to ask Mr. Georgios Spanos from FERTH to briefly summarize the angle that we are having in O-CEI. We are having several pilots that touch upon all these matters: decentralized ID, data sovereignty, DLT. We had IOTA in our consortium as well represented, although they will just participate from the technological perspective as open source. Also Power Ledger that participated at the beginning of the day will be incoming as partner of the project. So we believe we are pretty aligned with all these matters. Also IDSA, data spaces, concepts, etc. So just wrapping up how we will instill all these concepts in our project, I pass the floor to George Spanos, and if we have time later after his presentation, we might get some other questions from the audience to conclude the session. So the floor is yours, George. Thank you very much.
Thank you very much, Nacho. First of all, I think please confirm that you can see my screen and you can hear me well.
Yes, both things.
I will briefly, as Nacho said previously, I will briefly update you regarding the view of O-CEI for the DLT and data management. I'm Georgios Spanos from the Center for Research and Technology last part of this ambitious and innovative project. Let's start with the approach of O-CEI for data and identity management. In this slide, we can see the high-level architecture of O-CEI platform. We can see also highlighted the main components in this architecture that are related to today's subject about federated identity management and authorization, the cross-domain smart contracts, how we can use DLT for trust and reputation, and specifically for accountability, traceability, and reputation, and of course how we are going to handle the data governance. So O-CEI platform facilitates the realization of this computing continuum and tries to enable a trusted information exchange. We are going to implement and we are going to use top-notch technologies in order to ensure this data governance, traceability, confidentiality, and privacy, all important aspects of our platform. Of course, as I said previously, an important factor is also the building of trust and sovereignty by restricting specific to authorized information and resources. And regarding the data governance, we are going to implement a federated marketplace and of course be aligned with key initiatives such as DOM, IDSA, and Gaia-X. We are going also to follow a zero-trust federated identity management schema, and this platform will act as a broker for secure and seamless resource access. And also, we are going to have our specific digital passport. Also, as I said previously, we are going to adopt the smart contract technology, and agreement will be enforced through this technology. And finally, regarding accountability and traceability, these two aspects will audit critical actions performed by users with a digital passport. Some possible solution for this could be IOTA Tangle, already presented today in our presentation. We are going also to present today briefly, very briefly, another initiative that can be a proposal and draft, not of course to use the specific infrastructure, but since as a member of the consortium operates on the European blockchain service infrastructure, also operates one of the two nodes in Greece, we believe that some basic concepts can also be included with other technologies. What is the European blockchain service infrastructure? Is an infrastructure that offers cross-border public services. Using this infrastructure to cooperate via cross-border public services, connect existing solution, or integrate specific service. And there are some specific use cases in EBSI, this European Blockchain Service Infrastructure, that can also be helpful for our solution. Also, we have a CERT IDI wallet that is conformant with the version 3 of the EBSI conformance testing. And in order to close very briefly this presentation, some specific use cases that existing in EBSI are the notarization of documents, and this using DLT technology in order to verify authenticity and integrity of files. This is also similar and can be used for authenticity, integrity of data. And also regarding SSI, European Self-Sovereign Identity, we can see a specific graph in the right side of this slide in order to how the registration, authentication, and verification can be enhanced and can be improved by this kind of technologies. That's all from my side. I think I was very quick, not so at all, in order not to waste your time. If there are any comments on this,
thank you.
Of course,
George,
we are in month 2 of the project, and it is reasonable that some technologies are not so specific right now, but we are going to be much more specific and using the corresponding technologies very soon.
Okay, thank you very much, George. Also, from our side, I must say that we have not wanted to be super specific here list of technologies, because as you have seen from Matthew and from Bernard, our use cases, although all related to energy, are very heterogeneous. So the good thing about building O-CEI in the way we're trying to build it as a marketplace and generic enough is allowing these kind of technologies such as the Ikerland solution, GaiaX, IOTA Tangle to come in and fit specific use case needs, basically. So thanks, George, for introducing our architecture, which basically is what will encompass and frame everything. And thanks also for mentioning EBSI, so that we have in mind that if needed, we can take use of this infrastructure, which is available across Europe and is related to the topic of today. So I would like to ask if there is any global question, both for George or Angelina or Madeleine or Mario, the latest interventions. If there are, please either raise your hand or let us know and we will try to accommodate. I don't see any hand raised, and I don't know here if we would have any specific question in the room for any of the latest speakers. Okay. Then we are good. So thanks very much all this last round of speakers as well for your contribution. I hope that we all have gotten some good takeaways out of today's meeting, like this presence of decentralized technology coming from open source and the participation of industry already in this field, such as with SMEs, such as Power Ledger having their technologies, or Ikerland coming in, providing digital support for this decentralization of identity and the immutability registration of exchanges in different ways in the energy sector, as well for how energy operators and providers such as EDF are involved, and how this is opening up both real use cases, as we have seen, and also sparking community-led initiatives. GaiaX, I-PSI, CIS, Energy DataX, these Cantera initiatives we have seen. So it's for us obvious that this is a vibrant environment that hopefully we will be able to exploit during O-CEI life cycle in the different pilots, and for sure it will be challenging, but we are setting the foundations for its usage. And before closing, I would like to kindly ask all the speakers and panelists present today to submit their material, to send their presentations to us, to the organizers of this workshop, so that we can gather them and make them available as well. And for sure, hope to see you soon and getting engaged in a conversation and in the community. And passing the floor to Rolf to conclude the session.
Yeah, I think it's my turn, to thank particularly Nacho, guiding us through the session today, but also O-CEI in general, as well as CEI-Sphere. Thanks again to all the speakers. As you know, we talk about a large-scale project. We have a cluster of large-scale pilots. So the session today was very important, to create the solution space, because, there will be not one linear path of implementation. There are certainly barriers to integrate the different modules, to adopt DLTs, whatever you have in mind. At the end of the day, the pilots have to demonstrate E2E, end-to-end services. I think that's a must. But, none of the solutions is closed. So it has to be modular and it has to be extendable and customizable depending on the different needs. So it was very important today. We have the solution space defined, I think for O-CEI, but also for the other project in the cluster, and that we have a starting point. And as mentioned, we need a flexible implementation because also both projects have open calls. So we will not go for one single site solution and then it's closed. So we have a dynamic nature of the project. And so we are happy to stay in touch with you, to keep you tuned and to inform you about the progress and the flexibility and the opportunities to interfere with the consortium and the ecosystem as such. So thanks again for all the speakers. The presentations were very nice prepared, and we got a very tangible and valuable information today. Thank you and wish you a nice rest of the day.
Thank you very much, everybody. Okay.
Bye.
Bye-bye.
Thank
Bye-bye.
you.
Bye.
Thank you all. Bye.
Bye. Thank you.
Thank you all. Bye-bye.
Bye.
Bye.
Bye-bye.
Bye-bye.